Hello there and welcome to Life Beyond Seen, where curiosity drifts a little slower and science hums softly beneath the surface. Tonight, we're going somewhere few minds truly linger long enough to imagine, a place so hidden that even the light gives up before it gets there. The Abyssal Zone, the deep sea, the silent world that covers more of our planet than any other landscape, and yet remains almost entirely unknown. It's a place that feels more alien than the surface of Mars, yet is right here on Earth, just a few kilometers below our feet, under waves that never stop breathing. Before we begin our descent, I wonder, have you ever stood at the edge of the ocean and felt it look back at you? That strange stillness, that tug in your chest, the quiet sense that you're being observed by something impossibly vast and old. It's not just the sound of water or the pull of the tide, it's something deeper, something that waits. If you find these slow journeys through science and mystery to be a pleasant way to end your day, I'd be grateful if you gave this a like and maybe subscribed. It helps others find this little corner of calm, where curiosity and comfort can share the same current. So take a slow breath, let the day fade behind you, and imagine we're standing together on a moonlit shore. The sea is dark, the air is cool, and the horizon has dissolved into shadow. Somewhere out there beneath that black water lies the abyssal plain, stretching farther than the eye or imagination can measure. That's where we're going, not in a rush, but slowly, carefully, letting the pressure of the world above fade away. The ocean begins gently. The first few meters are familiar. You can see the shimmer of sunlight, watch it scatter across small waves and dance in plankton. Fish move like fragments of glass. Every colour still exists here. Blues and silvers, flashes of orange and green. The water hums with life and movement. But as you sink lower, things start to change. The brightness fades, replaced by a heavy blue that thickens with each metre. Sounds grow duller, slower, as if the water itself has decided to muffle the world. At about 200 metres down, the sunlight has already weakened to a twilight haze. Below that, you enter the midnight zone. Beyond this, even the word dark doesn't quite capture it. Darkness on land is still filled with echoes, starlight, street lamps, a sense of open air. But down here, darkness isn't the absence of light. It's a presence, a pressure, a weight that surrounds everything. When we talk about the Abyssal Zone, we're talking about depths between roughly 4,000 and 6,000 metres, though the boundaries are more poetic than strict. It begins where sunlight stops reaching entirely and ends just above the deepest trenches that scar the ocean floor. Imagine that distance. If Mount Everest were flipped upside down and plunged into the sea, its peak would still fall short of touching the abyssal floor. Down there, the water above you isn't just water, it's a crushing mass of billions of tons, pressing with such force that every square inch of your body would feel as though it were carrying the weight of an elephant. Human lungs would collapse instantly, bones would fail, even the strongest steel bends like clay. Yet this world exists, perfectly real, untouched by air, unseen by sunlight, and it's been there since long before we learned how to measure time. The strangeness of the abyss isn't only in its pressure or its darkness, it's in the way it erases all sense of scale. Distances feel endless because there's nothing to measure them against. Objects drift, not falling, not floating, just existing in slow motion. Even the idea of down loses meaning. On land, gravity feels clear, directional, comforting in its consistency. But beneath 6 kilometres of ocean, it's hard to know which way is down when every movement feels like it's happening through syrup. The water temperature hovers near freezing, barely above zero. There are no seasons, no day or night, just an eternal cold stillness. And yet, for all that stillness, this world is alive. Not in the way we know it, with colour and motion and warmth, but in quiet persistence. There are creatures that drift through this blackness, blind and luminous at once. their bodies shaped by forces we can hardly imagine. They move slowly, conserving energy because food is rare and the distances between meals can be vast. The abyss is not empty. It's simply hidden, operating on timescales and rhythms we don't share. When a whale dies near the surface and its body sinks, it becomes a kind of feast that can sustain an entire micro-ecosystem for decades. There are worms that live on bone, bacteria that digest oil, fish whose bodies glow with chemical light. Down here, life is patient. It's strange to think that this world, larger than all of our continents combined, is mostly unknown to us. Less than 1% of the abyssal plain has been directly explored. We have better maps of Mars and the Moon than we do of our own sea floor. That isn't because we haven't tried. It's because the deep ocean resists us. Every attempt to reach it is a battle against physics itself. Pressure is the enemy. Communication is the enemy. Distance and darkness are the enemies. The further we go, the harder everything becomes. And even when our machines survive the journey, what they bring back are glimpses, fragments, brief moments of clarity surrounded by hours of static. The abyss doesn't give up its secrets easily. Our story of trying to explore the deep sea begins, as so many stories do, with curiosity and arrogance intertwined. The first humans to imagine what lay below the waves thought of monsters, giant squids, endless chasms, serpents that could swallow ships whole. For centuries, the ocean floor was more myth than science. Sailors would drop lead lines with bits of tallow on the end, hoping to bring up some trace of the bottom, mud, shell, or sand. But beyond a few hundred meters, even that simple task became impossible. The line would drift, snap, or return clean, as if the sea itself refused to be measured. For a long time, we simply assumed the deep was lifeless. Too cold, too dark, too far from the sun to support life. It wasn't until the late 19th century, with expeditions like the HMS Challenger, that we began to see hints of something more. The Challenger was a converted British naval vessel, fitted with the best scientific instruments of its time: nets, dredges, thermometers, and pressure gauges. Between 1872 and 1876, it sailed nearly 70,000 nautical miles, lowering equipment into depths no one had dared before. When the crew pulled their nets back up, they found them filled with strange creatures, brittle stars, translucent sea cucumbers, and bizarre fish with eyes adapted to near darkness. It was proof that life existed even in the deep. But the technology of the time couldn't go far enough. The abyssal zone remained out of reach, a rumour confirmed only by the debris that drifted up from below. It wasn't until the 20th century that we began to send machines capable of descending beyond the twilight zones of the sea. Steel spheres with windows the size of dinner plates, thick cables connecting them to the surface, brave humans sealed inside breathing compressed air and uncertainty. One of the earliest was the bathysphere, designed by engineer Otis Barton and naturalist William Beebe in the 1930s. Suspended by a single steel cable, they descended more than 900 metres, far beyond what anyone had seen before. Through their tiny porthole they described glowing jellyfish, transparent shrimp, and eerie shadows that flickered in the distance. But even then, they barely touched the upper edge of the abyss. The pressure at that depth was already crushing, and the slightest flaw in the sphere could have meant instant death. There was no radio communication, only a telephone line that could fail at any moment. It was exploration at its most literal, dangling between curiosity and catastrophe. Since then, technology has improved, but the ocean has not grown kinder. Modern submersibles like Alvin and Limiting Factor have reached incredible depths, some even descending into the Mariana Trench, the deepest known point on Earth. But these missions are rare, expensive, and dangerous. A single deep-sea dive can cost millions of dollars and take years of preparation. Every piece of equipment has to be custom-built to withstand pressures over 1,000 times that of the atmosphere. Even the smallest leak or material defect can destroy a vessel instantly, and once you're down there, you're utterly alone. Radio waves can't travel through seawater. Light can't reach you. The only connection to the surface is a tether, a thread thinner than hope, carrying data at a fraction of the speed we're used to. Exploring the abyss is like trying to whisper to a friend through miles of stone. We've built incredible machines to face those conditions, but they all share a limitation: fragility. The deeper they go, the slower they must move, the more cautiously they must operate. Every component has to be tested against crushing pressure, salt corrosion, and absolute darkness. Cameras need special housings, batteries lose efficiency in the cold, propellers stall in thick sediments, and if something goes wrong, there's no rescue. The abyss doesn't allow do-overs, it doesn't return what it takes. That's part of why, despite all our advances, we still know so little. Remote-operated vehicles and autonomous drones can send back images, but they're limited by what their sensors can see. And sight itself is nearly useless at those depths. Light doesn't travel far underwater. Even the brightest lamps illuminate only a few meters ahead before being swallowed by darkness. Sound waves travel better, which is why we use sonar to map the seafloor. But sonar gives us shapes, not textures, outlines, not colours. It's like exploring a city by listening to echoes. You can sense its form, its density, its silence, but not its life. That's why every glimpse of a new creature from the abyss feels like seeing something from another planet. It's not that they're rare, it's that they exist beyond the edge of our senses. When we do catch them, sometimes by accident, they often die before reaching the surface. Their bodies, adapted to the crushing pressure below, rupture as they ascend. Their delicate forms collapse, their colours fade. What we see in laboratories are ghosts of what they were. It's as if the abyss only allows its inhabitants to exist within its own realm. To bring them into our world is to destroy them. That, perhaps, is the truest reason we can't explore the abyssal zone completely. It's not only that our machines fail, it's that the very act of exploration changes the thing we're trying to understand. To observe the deep is to disturb it. To study it closely is to destroy what makes it what it is. Still, we try. Humans are restless creatures. We've climbed mountains, crossed deserts, and left footprints on the moon. The idea that there's a part of our own planet still hidden, still untouched, gnaws at us. The abyssal zone is Earth's final mystery, and that makes it irresistible. But it's also a reminder of something humbling. Not everything can be conquered. Not everything should be. The deep sea isn't waiting for us. It's simply existing, indifferent to whether we ever see it. And maybe that's the point. Maybe there are parts of the world that need to stay quiet, unmeasured, unknown, so that wonder itself can survive. And as we drift here, imagining the cold silence far below, we begin to sense that this descent isn't only into the ocean, but into the limits of what we can know. The deeper we go, the more the world above starts to fade. Sunlight becomes memory. Sound becomes vibration. Time stretches. You can almost feel the weight of kilometers of water pressing above you, not threatening, just steady. A reminder that we are small, that curiosity has boundaries, that even our brightest lights are swallowed by the sea. But we keep descending slowly, carefully, toward a world that defies us simply by existing. Because somewhere beneath all that darkness, beneath all that pressure and silence, lies the question we can't stop asking. How far can we go before the world itself says, no farther? If you keep sinking past the sunlight and the flicker of the last known colour, you begin to realise that what lies below isn't just another part of the ocean. It's the ocean beneath the ocean, a separate realm with its own laws, pressures and inhabitants. We tend to imagine the sea as one continuous body of water, but the truth is more layered than that. The upper ocean, the part we swim in and sail across, is only a thin glaze on the surface of something much deeper. The world beneath that glaze is the largest living space on Earth, and yet it remains almost completely invisible. If we could somehow drain all the oceans, what we'd find is a landscape more dramatic than any mountain range. more desolate than any desert, more alien than any distant planet we've ever sent a probe to. The abyssal plane alone makes up over half of the Earth's surface. Think about that for a moment. Half of our planet is covered by terrain we've barely seen. Most of what we know about it comes from sonar readings and occasional glimpses from deep-sea submersibles, each capturing moments no longer than a breath compared to the scale of the ocean's lifetime. The maps we have are mostly guesses filled in between long stretches of nothing. You might expect the seafloor to be flat like the bottom of a pool, but it isn't. It's riddled with mountains taller than the Alps, canyons deeper than the Grand Canyon, and plains that stretch for thousands of kilometers with no sign of interruption. In some areas, undersea volcanoes still rumble quietly, releasing heat and minerals into the black water, while in others, tectonic plates grind past each other in slow motion, shaping the world without a sound. When we talk about the deep, we're not just describing depth in meters or kilometers. We're describing a transition from one type of existence to another. The ocean changes character as you descend. The upper layers move, churn, mix and breathe with the atmosphere. They respond to wind and weather, to the heat of the sun, to the pull of the moon. But farther down, below 2 or 3 kilometers, that relationship fades. The water becomes still, heavy, and ancient. It moves so slowly that a single current might take 1,000 years to complete its circuit around the globe. Down here, time behaves differently. The water that brushes against the abyssal floor could have been last at the surface before recorded history. You could call it fossil water, not because it's stone, but because it carries memory. Every molecule that sinks carries the story of the surface it once knew, the heat it absorbed, the salt it gathered, the gases it carried, and that information travels slowly through the darkness, like a whisper that takes centuries to arrive. This slowness defines everything in the abyss. It's not a place of constant activity, but one of endurance. The creatures that live here have evolved to survive in a world where energy is scarce, movement is costly, and change is rare. They are the ultimate minimalists of biology. Many of them have fragile gelatinous bodies because density is a liability. The less solid you are, the less likely you are to be crushed. Some have no eyes at all because sight serves no purpose where light never comes. Others have evolved bioluminescence, producing their own light not to see, but to communicate, attract mates, or lure prey. The flicker of blue-green light that these animals emit is the only true colour in this world, and even that is faint, brief and functional. In a way, the deep ocean glows with a kind of ghostly intelligence, each pulse of light a survival tactic disguised as beauty. Humans have a tendency to think of exploration as progress, as the act of uncovering what's hidden and taming what's wild. But when we look at the abyssal zone, we're faced with something that resists that narrative. The abyss doesn't ask to be understood. It doesn't yield easily. Its very nature makes it inhospitable to the tools we use to measure and study it. Even the idea of a bottom is misleading. What we call the sea floor is often a thick layer of fine sediment, accumulated over millions of years from the slow rain of particles drifting down from above. Dead plankton, microscopic shells, dust from distant continents, even the remnants of meteorites. This material settles into a blanket that can be hundreds of meters thick, soft and shifting like powdered glass. To land on it without sinking requires careful balance, delicate machinery and luck. And once a vehicle stirs it up, the resulting cloud can hang in the water for hours, erasing visibility and confusing instruments. The deep sea guards its privacy with mud. The pressure here is beyond anything we can truly imagine. At 4,000 meters, it's roughly 400 times the pressure at the surface. For comparison, that's like stacking the entire Empire State Building on your fingertip and then trying to keep a straight face. Most materials we use for everyday life simply fail under that kind of stress. Steel bends, glass shatters, rubber loses its flexibility, electronic short-circuit, even the smallest imperfections, a bubble in the weld, a scratch in the metal. can become points of catastrophic failure. To survive, submersibles must be engineered with near-perfect precision. The smallest mistake means collapse. That's why deep-sea vehicles often look simple, almost primitive. Spherical shapes, minimal openings, thick walls. There's no room for elegance in the abyss, only function. And yet, despite all this, the abyss is not static. It's shaped by currents and eruptions, by life and decay. Even in this darkness, there are weather systems of a kind. Slow, vast flows of cold water creeping along the seafloor, carrying nutrients and sediments across continents. These flows connect the ocean's deepest regions in ways that mirror the atmosphere above. When scientists speak of global circulation, they're talking about this deep heartbeat of the planet, the slow-motion conveyor belt that keeps the oceans alive. Without it, the surface would stagnate, marine life would collapse, and climate as we know it would unravel. The abyss may seem remote, but it sustains everything above it. It's the unseen foundation of all life on Earth. We sometimes imagine the ocean as something separate from us, but in truth, it defines us. Every breath you take owes something to it. The oxygen you inhale comes not just from forests and plants, but from tiny organisms called phytoplankton, drifting in the sunlit shallows above the abyss. These creatures depend on nutrients that rise from the deep. The ocean is a single breathing organism. The abyssal zone is its lungs. When we disturb it, we disturb ourselves. That's one reason why scientists are cautious about deep-sea mining, the growing industry that seeks to harvest metals and minerals from the seafloor. These deposits, like manganese nodules and cobalt crusts, have formed slowly over millions of years. They sit on the abyssal plains like forgotten coins, tempting in their abundance. But to collect them means scraping away entire ecosystems we barely understand. The creatures living there might never recover. The sediment stirred up could spread across thousands of kilometers, smothering life and altering the chemistry of the ocean for centuries. The problem isn't just what we take, it's what we destroy without realizing it. When people hear about the deep sea, they often think of it as empty space, a black void. But the truth is, it's full of organisms, full of mystery, full of ancient cycles we barely comprehend. Microbes in the abyssal mud break down organic material that drifts from above, recycling it into nutrients. Without them, the planet's carbon balance would collapse. The deep is a hidden engine of stability, quietly processing the waste of the surface world. Every piece of plankton that dies, every fish that decays, eventually becomes part of this grand recycling system. You could call it the Earth's slow metabolism. And like any living system, it depends on balance. We don't yet know how easily that balance can be broken. There's another challenge that makes the abyssal zone so resistant to exploration: temperature. At the surface, sunlight and weather create constant variation. But down here, the temperature is almost completely stable, just a few degrees above freezing year-round. This stability might seem peaceful, but it's also unforgiving. Machines must be designed to operate in conditions where metal contracts, batteries lose power, and lubricants freeze. Most electronics generate heat, which in a vacuum might dissipate easily. But in the dense water of the deep sea, heat has nowhere to go. That means systems overheat even in near-freezing water. It's a constant battle between two extremes, crushing cold and mechanical heat, both working to end the mission before it begins. Even the sound behaves differently here. In the open air, noise fades quickly, scattered by wind and absorbed by trees or buildings. Underwater, it travels far and fast. Whales use low-frequency sounds that can cross entire oceans. But in the abyss, even that vast communication begins to fade. The deeper you go, the more muted the world becomes. Scientists describe it as a kind of sonic fog. Submersibles can hear their own engines echoing off invisible mountains miles away, yet can't distinguish where the echoes come from. Navigation becomes guesswork. Instruments must interpret the echoes and build maps from them. But the ocean is full of reflections, false signals, and shifting layers of temperature that bend sound in unpredictable ways. What looks like a mountain might be a shadow. What sounds like open space might be a wall of rock. It's an environment built to confuse. This confusion extends to our understanding of life down here. The few creatures we've seen are often only those that happen to wander near a camera or submersible light. Many of them are soft-bodied, transparent, or small enough to drift unseen through nets. When researchers lower traps or sampling devices, they're often shocked by how quickly unknown species appear. Entire families of animals have been discovered from single specimens. Some scientists estimate that as much as 90% of abyssal life is still undescribed. Think about that. Entire branches of the tree of life, existing quietly just a few kilometers below us, never seen, never named. The deeper we look, the more we realize how little we know. And the irony is that the more sophisticated our machines become, the more we learn that knowledge isn't the same as understanding. Seeing something through a lens doesn't mean you grasp what it is or how it lives. It only means you've glimpsed it long enough to know that you're missing almost everything. That sense of distance isn't just physical, it's philosophical. The abyssal zone exists at the limit of what our senses can process, and so it challenges how we think about exploration itself. We like to believe that with enough technology there are no limits, that every place can be reached, every mystery solved. But the deep ocean refuses that belief. It reminds us that the universe, even here on our own planet, still contains places that will never be fully ours. The abyss doesn't need us to see it to be complete. It simply is, and maybe that's why it fascinates us so deeply. It's one of the few places left that doesn't depend on our gaze to exist. As we hover here, somewhere between the known ocean and the black expanse below, it's easy to feel a kind of reverence. The water thickens, the light disappears entirely, and the only sounds are mechanical hums and faint pops from the hull, expanding and contracting under pressure. Instruments flicker softly, showing graphs of temperature, salinity and depth, but none of it captures the feeling of the place. There's something almost human about our need to describe it anyway, to translate the ineffable into data. We lower probes, collect samples, analyze sediment cores, and give names to places no one will ever stand. We do it not because it changes the abyss, but because it changes us. Every time we look into the deep, we're reminded that we are temporary, fragile, and curious. Three qualities that together define what it means to be alive. And so, the ocean beneath the ocean continues to whisper from the darkness, indifferent to our curiosity yet essential to our survival. It's the planet's memory, holding the stories of ancient climates, extinct species, and forgotten continents. Within its sediments are records of ice ages and extinctions, volcanic eruptions and meteor impacts. To study it is to read the biography of Earth itself. But the text is incomplete, missing pages, written in a language of pressure and silence. The deeper we go, the more that language becomes impossible to translate. And yet, we listen. Down here, the concepts that define our daily lives, light, colour, time, motion, lose their meaning. There's only distance and density, only the slow drift of unseen life. If you stayed long enough, you might forget the surface altogether. The abyss has that effect. It invites you to stop measuring, to stop naming, and simply exist. But of course, we can't stay. Our machines can only last so long, and our bodies even less. The ocean allows us brief visits, glimpses through tiny windows, moments of awe before it closes again behind us. We rise slowly, careful not to ascend too fast, carrying with us the memory of what we've seen and the uneasy knowledge that most of it will remain unseen forever. As the light returns, faint at first, then brighter, we understand something new about the world above. the surface, the waves, the sunlit shallows. All of it depends on the deep. The ocean beneath the ocean isn't just a place. It's the hidden half of our planet, the foundation on which everything else floats. And as we begin to leave its darkness behind, we can't help but wonder what else lies below, what other boundaries we haven't yet reached, and whether some parts of the world are meant to remain beyond reach, at least for now. Because the more we learn about the abyss, the clearer it becomes that the real mystery isn't just how deep it goes, but why, after all this time, we still feel compelled to follow it farther down. The deeper we go, the more the world begins to dissolve into something unrecognizable. Light, that quiet architect of everything we know, begins to vanish. It doesn't fade all at once, but rather in stages, thinning like mist until it becomes memory. Every metre deeper takes us further from the sun, and with that distance comes a kind of unmaking. Colours disappear first, one by one, as if the ocean is erasing its own palette. Red goes first, swallowed by the water within the first few dozen metres, then orange, then yellow. By the time you've descended a few hundred metres, even green begins to lose its voice. All that remains is blue, and even that eventually goes silent. Below 1,000 metres, there's nothing left for the eye to see. The world becomes a blank canvas of black pressure. It's a strange thing to realise that most of Earth's biosphere exists in this darkness. We think of sunlight as life's great provider, and on the surface that's true. But down here there are no sunbeams, no warmth, no photosynthesis. The deep ocean is powered by something else entirely. It runs on decay, on the slow rain of organic material drifting down from the world above. Scientists call it marine snow, a delicate cascade of dead plankton, fecal pellets, bits of tissue, and tiny fragments of detritus. It falls constantly, gently, from the upper layers to the deep, sometimes taking weeks or months to reach the seafloor. To most of us that sounds grim, but to the creatures of the abyss, it's sustenance. Every flake of that snow is a piece of sunlight transformed through countless forms of life, before finally reaching the dark. The deep sea doesn't make its own light, but it feeds on the echoes of it. For humans, darkness often carries a sense of danger, of the unknown waiting to reveal teeth. But the darkness of the deep ocean isn't threatening. It's absolute. It's total. It leaves no space for fear because fear requires imagination, and imagination needs something to see. In this place, there's simply nothing. The absence of light strips away the familiar cues the mind depends on. Up and down lose their meaning. Movement becomes a guess. The senses that keep us grounded at the surface, sight, sound, orientation, fade into irrelevance. All that's left is the low hum of instruments, the faint creak of a submersible hull adjusting to pressure, and the steady rhythm of your own breathing made louder by the silence around it. Down here, you begin to understand how much light defines our concept of reality. Without it, space itself feels like an illusion. The abyss doesn't reflect, it doesn't shimmer or sparkle. Even when artificial lights from submersibles cut through the darkness, they create more mystery than clarity. The beams pierce only a few meters before being swallowed. The water absorbs and scatters the light until it's like trying to see through smoke made of water. Every object appears closer and flatter than it is. Shapes emerge, glint, then vanish, leaving you unsure whether you've truly seen them or imagined them. It's a place where light doesn't illuminate so much as intrude. Every burst of brightness feels like an act of violence, a reminder that we don't belong here. The creatures that live in these depths respond accordingly. Some flee from light as though it burns them. Others are drawn to it, mistaking it for prey. To them, light means disruption, an unfamiliar energy in a world that prefers to stay hidden. And yet, paradoxically, this is also a world that creates its own light. Bioluminescence is one of the most common forms of communication in the deep sea. Bacteria, jellyfish, fish, squid, Even worms have evolved the ability to produce light through chemical reactions inside their bodies. It's a kind of cold fire, a soft glow generated without heat, efficient and silent. Some creatures use it as camouflage, matching the faint shimmer of the water above to hide their silhouettes from predators below. Others use it as a lure, like the famous anglerfish, whose dangling luminous bait attracts curious prey into its waiting mouth. Still others use light to communicate, flashing patterns to signal mates, warn rivals or confuse hunters. In the deep ocean, light is both weapon and language. Each of these displays is precise, evolved through millions of years of adaptation, some flash impulses lasting mere milliseconds, invisible to slower eyes. Others release continuous glows that drift like underwater lanterns. The colours vary too, mostly blue or green, the only wavelengths that travel far in seawater. But a few species can produce red or even violet, creating a secret spectrum invisible to most predators. Watching footage of bioluminescent displays from deep-sea expeditions feels like watching an alien city from a great distance. Pinpoints of light flickering against endless black, signalling across the void. The irony is that these creatures have no eyes capable of seeing the beauty we do. Their light isn't art, it's survival. For us, it's hard not to read poetry into it. We see these sparks as reminders of resilience, as proof that life always finds a way. But the reality is colder and more elegant. Bioluminescence isn't defiance against darkness, it's an adaptation to it. In a world where energy is precious, every glow must justify its cost. Each flash is a calculation, a trade between exposure and communication. To shine too brightly is to be eaten. To stay dark is to be alone. Life in the deep lies between those extremes. This duality, light as both saviour and threat, is part of why the abyss remains so difficult for us to explore. The machines we send down must carry light to sea, but that same light scares away what we're trying to observe. Imagine trying to study nocturnal animals in a forest using a spotlight that blinds everything it touches. Every time we illuminate the deep, we alter it. The creatures retreat. The natural patterns vanish. What we capture on film are glimpses, not truths. To truly understand the deep, we would need to see without seeing, to invent instruments that sense without disturbing. We're working on it, but for now, every descent is a negotiation between curiosity and intrusion. What little we've recorded is breathtaking. There are fish that look like ribbons of glass, their organs visible and shimmering faintly as they move. There are jellyfish the size of dinner plates with tendrils stretching meters behind them, pulsing in slow rhythm. There are shrimp that produce flashes so bright they can temporarily blind predators. Some squid eject glowing ink, clouds of blue light that linger like underwater ghosts. Even microscopic plankton join the display. When disturbed, they sparkle like dust in a beam of sunlight. Tiny stars scattered in reverse, shining not from above but from below. If the surface world is bathed in sunlight, the deep ocean is sprinkled with fireflies. And then there's the darkness that remains between those sparks, the overwhelming continuous black that no light can penetrate. Scientists sometimes call it the aphotic zone, literally meaning without light. It's an honest name, though perhaps too mild for what it describes. In reality, this is a place where light doesn't just fade, it ceases to exist. The very concept of illumination loses meaning. There are no shadows here because there's no source to cast them. Everything is equally unseen. If you turned off your submersible lights, you wouldn't just see nothing, you'd lose all sense of space. You could hold your hand an inch from your face and have no idea it was there. Even the idea of direction becomes abstract. Without light, there's no horizon, no surface, no bottom. Just blackness stretching infinitely in every direction. This absence of light also changes how sound moves. Because there's no heat from sunlight to create temperature gradients, the water here is nearly uniform in density. that allows sound to travel long distances with little loss of energy. Some deep-sea animals have evolved to take advantage of this, using low-frequency vibrations to communicate across vast distances. Others have developed specialized organs to detect those vibrations. The abyss may be dark, but it isn't silent. It hums faintly with the clicks, groans, and pulses of creatures we've barely identified. Even the Earth itself contributes, a constant tremor of tectonic motion, volcanic murmurs, and the distant roar of storms filtered down from the surface. If you could somehow translate those vibrations into sound, it might resemble the background hum of a planet breathing. The creatures that live here have bodies shaped not only by darkness, but by the need to feel their way through it. Many have elongated fins or sensitive whisker-like appendages to sense movement in the water. Others use electric fields to navigate, generating small currents that bounce off nearby objects. Some, like certain species of fish, can detect the faintest glimmer of bioluminescence from meters away. It's a world built on touch and vibration, a symphony of invisible cues. Where we rely on light to make sense of the world, they rely on the subtle patterns of pressure and pulse. In that sense, they're more attuned to the ocean's heartbeat than we could ever be. When early explorers first reached these depths, they assumed that nothing could live here. It seemed impossible that life could exist without sunlight. But as it turned out, life not only exists, it thrives. In some places, communities of organisms cluster around hydrothermal vents, where seawater heated by magma escapes through cracks in the seafloor. These vents release minerals and chemicals that serve as the foundation for ecosystems independent of sunlight. Instead of photosynthesis, which uses light to produce energy, these creatures rely on chemosynthesis, harnessing chemical reactions from the vent fluids. It's a completely different blueprint for life, one that showed us that the sun isn't the only possible source of energy. The discovery of these vent ecosystems changed biology forever. It proved that life could exist in total darkness, fueled by the chemistry of the Earth itself. That revelation had implications far beyond the ocean. It suggested that life might exist elsewhere in the universe, on planets and moons without sunlight but with heat and liquid water beneath their surfaces. Worlds like Europa or Enceladus, icy moons orbiting Jupiter and Saturn, may have oceans similar to Earth's deep sea. If life can thrive here, why not there? In that way, the abyss isn't just a mystery of Earth. It's a key to understanding the universe. The darkness beneath our waves might not be so different from the darkness between the stars. But for now, we remain outsiders looking in. We light up the deep for moments at a time, then retreat. Every image, every sample, every data point is a temporary bridge between our world and theirs. The creatures we study return to the dark when we leave, their lights flickering briefly before fading back into invisibility. It's easy to think of them as strange or alien, but in truth, they are the majority. For every animal that lives in sunlight, there are countless others living in the dark. Life on Earth is, by volume, a creature of shadow. We are the exceptions, the surface dwellers who rely on a single star. The deep doesn't need it. The deep has learned to live without it. That thought is both humbling and unsettling. We like to imagine ourselves as explorers of the unknown, shining lights into darkness, expanding the realm of the visible. But down here, light doesn't expand anything. It distorts. It interrupts. The abyssal zone doesn't need our illumination to exist. It simply waits for the light to fade again. Maybe that's why every descent feels temporary, even symbolic. A reminder that not all exploration is conquest. Some of it is simply bearing witness, however briefly, before the darkness closes again. If we could stay long enough, if our machines were quiet enough, perhaps we'd begin to understand this world on its own terms. But we're not built for such patience. The human mind craves patterns, edges, contrasts. It wants to see. In the abyss, there are no edges, no colours, no clear shapes. There is only transition. the slow blending of existence into nothingness. It's not a place that reveals itself, it's a place that absorbs. To look into it is to realize how much of our understanding depends on light, and how fragile that understanding becomes when light is gone. And as we drift deeper still, into a darkness that feels endless, we begin to sense that the ocean's greatest secret isn't what it hides, but how it hides it. Not through deception or danger, but through sheer indifference to our senses. The abyss isn't waiting to be discovered, it's simply there, vast and complete, unconcerned with whether we ever reach it. The light has already forgotten this place, and perhaps, in a way, so should we. But curiosity never forgets. It keeps sinking, chasing the faint glimmer of understanding that flickers somewhere below the last trace of blue. The deeper you descend, the more you start to feel the invisible weight of everything above you. It isn't the kind of pressure you can see or measure with your body. It's something that presses on the imagination first. Every meter down adds another layer of water, each one heavier than the last, until the sea itself becomes an enormous weight bearing down on you. At the surface, pressure is gentle, the familiar one atmosphere that wraps around us without notice. But by the time you reach the abyssal zone, that pressure has multiplied by hundreds. Every square inch of a surface bears several tons of force. There is no pause, no mercy, no escape from it. The ocean at that depth is no longer just a liquid. It behaves like a solid in its density, a mass so immense that it's hard to believe anything can exist beneath it. And yet somehow things do. It's difficult to visualize what this pressure truly means. Numbers lose their meaning somewhere along the descent. You can say 6,000 pounds per square inch, or 400 times the air pressure at sea level, but those are abstractions. What that pressure does, what it feels like, is something else entirely. Imagine the strongest glass bottle you can find. Now imagine it crushed instantly into powder. Imagine metal plates warping like paper, air bubbles collapsing faster than you can blink, and cables snapping as though cut by invisible scissors. That is what the deep does to anything that isn't prepared. It doesn't roar or strike, it simply squeezes. The abyss doesn't destroy things with violence, it dismantles them with patience. Human beings weren't built for this kind of environment. Our bodies, designed for the thin skin of atmosphere on a spinning rock, are too fragile, too soft. A few dozen meters below the surface, a diver can feel pressure in the ears and lungs. At a few hundred meters, nitrogen saturates the blood, distorting perception and thought. Beyond that, no human can survive unaided. The abyss isn't simply uninhabitable, it's incompatible with life as we know it. And yet, we keep finding ways to touch it, to send our machines into that crushing dark, hoping that technology can make up for what biology cannot. Every submersible that descends into the deep carries not just scientists and instruments, but a quiet acknowledgement of risk. The walls of the vessel are thick, made from specialized alloys or composite materials, shaped to distribute stress evenly. The most reliable shape is the sphere, because pressure acts equally from all directions. Even so, engineers calculate, test and redesign constantly, because at these depths, even perfection is barely enough. There's a reason why the most advanced deep diving crafts have walls up to 12 centimeters thick, yet still small interiors barely large enough for a person to move. It's not to save space, it's to survive the weight. For the people inside, the awareness of that pressure never really fades. It's not something you feel physically. Inside the sphere, the air is normal, but mentally it's always there. The knowledge that just outside those walls is a force capable of crushing steel, like clay, creates a tension that's hard to shake. When explorers describe their dives, they often talk about how loud the silence feels, how each small creak of metal echoes through their bones. The deeper they go, the more those sounds blend with the rhythm of their heartbeat. A reminder that between them and instant collapse are just a few centimeters of human engineering. It isn't fear that drives them, but a kind of humility. The pressure outside is a reminder that nature doesn't yield, not even for curiosity. Pressure behaves strangely in the ocean. It doesn't just compress the hulls of submersibles, it changes the very properties of matter. Gases dissolve more easily in liquids, chemical reactions slow down. Water itself becomes slightly denser, its molecules packed tighter together. Even light behaves differently, scattering more quickly, losing its colour. The abyss is not just dark because sunlight doesn't reach it. It's dark because the physics of the place make light a fragile thing. In this world, everything bends towards stillness. Movement is costly, expansion dangerous, and even sound is shaped by the crush. A clap or explosion that would echo for kilometres in air becomes a dull, muted thud. There's no resonance here. The deep swallows everything. For living creatures, the challenge of pressure has led to extraordinary adaptations. Most abyssal animals have bodies without gas-filled spaces, no air in their lungs, no swim bladders, no hollow bones. They are made of water and tissue and jelly, materials that compress easily. That's the secret of their survival. Flexibility. The same force that would shatter a rigid object passes harmlessly through something soft. It's the opposite of our instinct. We build things to be solid, firm, unbending, and in the abyss, that's exactly what fails. Down here, survival belongs to the supple, to the things that yield without breaking. It's an elegant lesson the ocean keeps repeating. Sometimes strength means giving way. Some deep-sea fish produce special proteins that prevent their cellular structures from collapsing. Others have enzymes that function under immense pressure, but would fail instantly at the surface. Their biochemistry is tuned to an environment where compression is constant. Bring them up too fast and they die not from a lack of oxygen, but from decompression. The molecules that keep their bodies stable at depth expand and tear them apart when released. That's why so few abyssal creatures can ever be displayed alive on the surface. They aren't just from another place, they are made of it. Machines face a similar problem. Every component, from the smallest bolt to the thickest hull, must withstand conditions that push materials to their limits. Scientists have developed synthetic ceramics, titanium alloys, and carbon composites specifically for deep-sea exploration, each tested in pressure chambers that simulate the abyss. Even so, failures happen. Sometimes a window implodes, sometimes a seal leaks, sometimes the data cable snaps and the craft is lost entirely. In the deep, recovery is almost impossible. The ocean gives nothing back willingly. Many of the world's most advanced submersibles, probes and cameras now rest somewhere on the seafloor, intact or broken, surrounded by the silence they were built to study. The pressure doesn't just crush objects, it isolates them. Radio waves, which connect everything above the surface, can't penetrate water beyond a few meters. Communication relies on cables or acoustic signals, both of which are unreliable. Every message sent from the deep must travel slowly, distorted by currents and temperature layers. Sometimes a transmission takes seconds to reach the surface, sometimes minutes. There's no real-time conversation, no instant control. Pilots operate with a delay, responding to what the machine saw moments ago, steering through a world that's already changed. In a sense, all deep-sea exploration happens in the past tense. You never quite know what's happening around you right now. For the human mind, that isolation can be disorienting. There's no light, no sound, no clear sense of movement. Time stretches, bends, and loses coherence. Even inside a submersible lit by soft panels and instruments, you can feel the immense pressure of silence outside. Explorers describe moments when they forget they're moving at all, when the ocean feels infinite and still, when the line between inside and outside begins to blur. It's not claustrophobia, it's something deeper, a quiet awareness of being surrounded by the weight of the planet itself. Above you are kilometers of water, then the sky, then the rest of the world. Everything you've ever known is pressing down, layer upon layer, and yet, somehow, you're still here. That sensation has fascinated psychologists who study extreme environments. They note how prolonged exposure to isolation and pressure affects perception and mood. Some divers report feelings of euphoria, others of insignificance. The boundaries of self seem to soften. It's as if the mind mirrors the flexibility required for survival at depth. You stop resisting the weight and start accepting it, letting the knowledge of your smallness become a kind of calm. Perhaps that's why those who've been to the abyss describe it not just as a scientific experience, but a spiritual one. It's one thing to know the planet is vast. It's another to feel it physically pressing against you. In the natural world, pressure shapes landscapes as much as it does organisms. The seafloor isn't static. Under immense compression, the Earth's crust bends and folds. Mountains rise from volcanic ridges, valleys deepen into trenches, and fissures open where tectonic plates diverge. At those edges, where molten rock meets the freezing dark, hydrothermal vents spew mineral-rich water that fuels entire ecosystems. These vents exist because of pressure, the ocean forcing water deep into the crust, heating it and driving it back out again. Without that constant exchange between surface and depth, the planet's geology would stagnate. The weight of the world above isn't just a burden, it's part of the Earth's heartbeat. There's a strange symmetry to it. The same pressure that makes exploration nearly impossible also makes life possible in ways we don't fully understand. It maintains the ocean's structure, drives its currents, and shapes its chemistry. If the deep were less compressed, gases would escape, and the balance of oxygen and carbon dioxide would shift. The abyss is the Earth's natural pressure chamber, regulating the climate from below. When we study it, we're not just learning about the sea, we're learning about how the entire planet sustains itself. It's easy to forget that when we breathe, eat, or grow crops, we're indirectly depending on systems that stretch all the way down to the seafloor. The weight of the ocean above the abyss is what keeps everything connected. And yet, for all its power, that pressure remains almost invisible to us. It's easy to underestimate something that never announces itself. On the surface, the ocean looks calm, indifferent, almost gentle. The waves lap against the shore, the horizon glows with light, and somewhere beneath all that, entire mountain ranges lie buried under unimaginable weight. The stillness of the sea is deceptive. It hides the constant struggle of balance happening beneath. Each molecule of water presses against the one below it, transmitting the collective weight downward, all the way to the bottom. The abyssal plain, flat and silent, bears the load of the world. If it could speak, perhaps it would say nothing at all. Silence, after all, is what pressure sounds like. There are rare moments when that balance breaks. Submarine earthquakes, caused by the shifting of tectonic plates, release massive amounts of pressure in an instant. The result can be catastrophic. Tsunamis that race across oceans, reshaping coastlines thousands of kilometers away. Those events remind us that the abyss isn't passive. It stores energy quietly, for centuries if needed, and releases it in seconds. Every tremor, every shift is a whisper of that power. The same force that supports the world can also unmake it when disturbed. For humans, encountering that scale of force changes something fundamental. We're used to being in control of our environment, of bending nature to our will. But in the deep, control doesn't exist. You can't fight the pressure, you can only respect it. Every descent is a negotiation with physics. Every success is temporary. The ocean allows us glimpses but never surrender. The deeper we go, the clearer it becomes that this isn't a realm to conquer, it's a realm to endure. That may be why the stories of deep-sea exploration often sound less like triumphs and more like meditations on fragility. Each dive, each image, each discovery is framed by the quiet acknowledgement that one miscalculation could end everything. The abyss has no storms, no weather as we know it, yet it feels heavier than any thundercloud. It's a place defined not by movement, but by mass. You don't witness the weight directly. You infer it from the behavior of everything around you. The way materials deform, the way sound dulls, the way light vanishes faster than you expect. It's a world sculpted entirely by gravity and time. When you think about it long enough, you start to realize that the ocean isn't really separate from the planet. It is the planet, liquefied and set in motion. The pressure below is simply the Earth reminding us of its own scale. Above it all, the surface feels impossibly far away. The sunlight that once defined your sense of direction is now just an idea. If you looked up, there would be nothing to see, only darkness layered upon darkness. Somewhere above that, the atmosphere thins into space, another kind of pressure entirely, the inverse of this one. We live between those extremes, between crushing density and endless emptiness. The ocean's weight below and the vacuum above, those are the boundaries of life. Everything we know happens in the thin band between them. That narrow margin of safety defines what we call home. And yet, knowing all this doesn't stop the desire to go deeper. Curiosity seems to thrive under pressure, perhaps because it mirrors our own limits back at us. The abyss challenges not just our technology, but our imagination. What else could survive here? What new forms of life? What unknown materials? What hidden processes wait beyond our reach? The answers are probably countless, but for now, they remain locked beneath the weight of the world above. Each layer of water is a barrier of both physics and understanding. To pierce it is to fight against nature itself. Still, somewhere in that struggle is a kind of peace. The pressure is constant, predictable, and absolute. It doesn't waver or deceive. It simply exists. And maybe that's why those who've been to the depths speak of it not as hostile, but as honest. The abyss doesn't pretend to welcome you, it doesn't tempt or threaten, it just holds its weight. You either withstand it, or you don't. There's a strange comfort in that certainty, in knowing that something so immense is perfectly consistent. It doesn't change its mind, it doesn't negotiate, it just is. And as the lights of the submersible fade into the black once more, as the pressure continues to build and the instruments hum softly, you begin to understand that what we're exploring isn't just the ocean's depth. It's the idea of endurance itself. Everything that lives here, every machine that survives here, every scientist who studies it is part of that same quiet conversation with gravity. The abyss teaches patience, humility, and resilience. Not through words, but through weight. For as long as we've been aware of the deep, we've tried to touch it, to send something of ourselves into that darkness where human bodies cannot go. The idea of machines descending into places we can only imagine has always carried a peculiar mix of pride and melancholy. Every cable, every bolt, every curved wall of titanium we design is an attempt to extend the reach of our own curiosity. The ocean's weight may keep our lungs and bones from surviving down there, but our ideas, wrapped in steel and glass, continue to dream in our place. It's through these machines that we learn what it means to explore without being present. When the first submersibles were built, they were little more than reinforced cages with portholes. The bathysphere, a spherical chamber barely large enough for 2 people, hung from a cable that led back to a ship bobbing miles above. Inside, explorers like William Beebe and Otis Barton sat in cramped darkness, surrounded by the creaking song of the steel as it resisted the water pressing in from every side. The temperature dropped, the air grew thick with moisture, and the sound of the cable above them was their only connection to the world. There were no cameras, no electronics, no safety protocols that would make sense to us now. And yet, when they looked through that small window and saw the faint glimmer of living lights flickering in the distance, they understood that they were witnessing something no human eyes had seen before. The machines were primitive, but the dream was vast. It wasn't long before engineers realized that humans didn't need to be inside the machines at all. The risk was too high, the cost too great, and the information too limited. If pressure would crush a person, it could just as easily destroy a machine, but at least a machine could be replaced. That's when the deep began to fill with remote eyes, tethered probes, submersibles controlled by hands and minds safely above. We began to explore through screens and signals, building a relationship with the ocean that felt strangely intimate and distant at once. Each dive was a conversation with delay. A joystick moved, and seconds later a robotic arm reached. A camera turned, and somewhere in a control room, an image appeared on a monitor, pixel by pixel, of a world that existed half a dozen kilometers away. The challenge was always the same: to build something that could survive without strength, to make a machine soft enough to endure the hard world of the abyss. That meant abandoning the instinct for brute force and learning from the creatures that already lived there. Nature had solved the problem millions of years before us. Deep-sea organisms withstand pressure not by resisting it, but by matching it. Their bodies are fluid, their tissues filled with water, their internal pressures equal to the world around them. Engineers began to imitate that philosophy. Instead of making machines that fought the sea, they built ones that flowed with it. Rounded, smooth, compact, with flexible joints and adaptive systems. Some designs even borrowed ideas from biology: artificial muscles, self-healing materials, sensors modelled after the lateral lines of fish. In the end, every machine we send down is a kind of metal animal, learning to swim in a place that doesn't want swimmers. The shift from manned to unmanned exploration changed everything. Machines don't panic. They don't get cold. They don't need oxygen or food. They can stay in the abyss for days, sometimes months. They can drift, wait, and listen in ways humans never could. Modern remotely operated vehicles, or ROVs, are like extensions of our senses, connected to ships by long cables that carry power and data. Through them, scientists can manipulate the environment with precision, collect samples, take measurements, capture high-definition video. When you watch the lay feed from one of these dives, the sight is eerie. The light from the vehicle cuts through the dark in slow, steady beams, revealing creatures that drift lazily past, unaware or unconcerned by the machine among them. The robotic arms move with deliberate care, guided by human operators miles above who watch through screens, translating their instincts into mechanical gestures. The deep sea, in those moments, becomes a meeting place of patience and machinery. But even the best technology faces limits. The deeper we go, the longer the cables, the slower the response, the greater the risk of failure. Water eats away at everything, salt corrodes, pressure compresses, every dive is a test of endurance. Sometimes, after weeks of preparation, a mission ends because a seal leaks or a circuit board shorts out. Repairs take months. The ocean waits for no one. When you send a machine into the abyss, you're not conquering it. You're negotiating with it, hoping the balance holds long enough to glimpse something new. And when the machine returns, coated in sediment and scratches, it carries back not only data, but a kind of quiet evidence that it survived the impossible. Among the most remarkable of these machines are the autonomous underwater vehicles, or AUVs. Unlike their tethered cousins, AUVs travel freely, navigating the deep entirely on their own. They map, measure, and record without human guidance, guided by pre-programmed instructions and sensors that read the landscape through sound and magnetism. These are the true explorers of the abyss, machines that move in silence, without eyes, without fear, without the need for reassurance. Some are small enough to fit in a suitcase, others are the size of submarines. They travel for days beneath the waves, collecting information about temperature, salinity, and current, tracing invisible pathways through a world that is constantly in motion. The data they bring back is invaluable. From their measurements, scientists create detailed maps of the seafloor, revealing canyons, ridges, and plains that were once only vague outlines. They help track how the ocean circulates, how carbon moves through its depths, how climate patterns begin in places no sunlight reaches. But even their precision can't erase the feeling of distance. The maps are beautiful but incomplete. They show shapes, not textures. They record temperatures, not sensations. Machines can describe, but they can't perceive. They don't experience awe. They don't marvel at the bioluminescence of a drifting jellyfish or the stillness of a 1,000-year-old sediment plain. They see without seeing. And yet, through their mechanical eyes, we glimpse something close to wonder. Sometimes the connection between human and machine becomes almost poetic. Operators talk about their ROVs the way sailors once spoke of their ships, with affection, frustration, and respect. Each one has a personality shaped by its quirks and flaws. Some handle pressure better than others. Some move with a grace that makes their footage look effortless. Others are clumsy, prone to losing stability in currents, prone to bumping into rocks or stirring up clouds of sediment. When a machine is lost, the grief in a research team can feel personal. They don't just lose equipment, they lose a companion, a piece of themselves that dared to go where they couldn't. And occasionally those losses remind us how fragile our reach still is. One of the most haunting examples came in 2023, when the Titan submersible imploded during a descent to the Titanic. Though it wasn't a research mission in the traditional sense, its loss echoed across every community involved in deep-sea exploration. It was a tragic reminder that the ocean does not compromise. The pressure at those depths allows no mistakes, no shortcuts, no forgiveness. For all our technology, the line between success and disaster remains paper-thin. Even the most advanced engineering bows before the physics of the deep. Despite that, or perhaps because of it, the pursuit continues. Each generation of machines grows more capable, more aware, more attuned to the subtle demands of the environment. We now build soft robots that move like octopuses, flexible drones that flutter like jellyfish, and biohybrid systems that mimic living tissues to survive the crushing depths. Some designs don't even rely on electricity in the traditional sense. They use chemical reactions or pressure differentials to power themselves, drawing energy from the very environment that threatens to destroy them. These are machines that, in a sense, have learned to dream like the creatures of the deep, quietly, efficiently, without resistance. The idea of machines dreaming might sound strange, but in a way that's exactly what they do. When an AUV drifts through the abyss, following its programmed route, it's tracing the contours of a world we can't imagine in real time. It records data we won't see until it returns, and even then much of it remains beyond our immediate comprehension. The machine's memory becomes a kind of subconscious for humanity, a record of the unseen. When we download its findings, we're reading the dreams of something that has travelled through a place no mind could withstand awake. This strange relationship between humans and their machines speaks to something deeper about exploration itself. We no longer explore by stepping into the unknown, but by extending our reach through proxies. We send mechanical eyes, mechanical hands, mechanical minds. The human spirit of discovery persists, but it does so at a distance. We've become spectators to our own curiosity, watching as our creations descend into darkness and return with glimpses of a world that may never be ours. The dream of the deep has become theirs to live. In that sense, the abyss has become a kind of mirror. Every submersible, every probe, every cable we lower into it reflects something about ourselves. The persistence, the impatience, the inability to let mystery be. We build machines not just to explore, but to reassure ourselves that understanding is possible. Yet, the more we send, the clearer it becomes that understanding has limits. The machines record more data than we can process, uncover more patterns than we can explain. The abyss remains ahead of us, always slightly beyond reach, always deeper than the last measurement. The machines may dream of the deep, but the deep dreams back in silence, in pressure, in distance. Some of the most advanced explorations today are run almost entirely by artificial intelligence. Algorithms plan dives, adjust routes, and identify anomalies in real time, adapting to currents and conditions without human input. These systems can process sensory data faster than any operator could, distinguishing between rock and coral, life and sediment. In many ways, they explore more intelligently than we do. But even as we grant them autonomy, we're still driven by the same question. What are we hoping to find? The abyss is not hiding treasure or waiting to be discovered. It exists without agenda. The knowledge we seek there is as much about our own limits as it is about the ocean's secrets. When these machines return to the surface, what they bring back often feels anticlimactic. Graphs, sonar maps, hours of quiet footage showing drifting particles and barren plains. And yet, within that monotony, there are moments that change everything. A new species glimpsed for seconds, a pattern of sediment that reveals ancient climate cycles, a thermal vent no one knew existed. Each discovery is a fragment, but together they form a mosaic of the unknown. The deep is revealed not through grand gestures, but through accumulation. Our machines dream in data, and we interpret their dreams piece by piece. There's a certain poetry in that process, even if we don't admit it out loud. We build these vessels of metal and code. We lower them into the black and we wait for them to come back changed. When they do, we pore over the results, searching for meaning in numbers and images. The relationship feels almost parental, hopeful, anxious, proud, and humbled all at once. We send them out knowing they might not return. We build them knowing they'll probably fail eventually. And yet, we keep building. Each new failure becomes a lesson, each success a small step deeper into understanding. Even now, as technology grows more precise, the gap between what we know and what we don't continues to widen. For every sensor we deploy, there are 1,000 phenomena we still can't explain. For every kilometre mapped, there are 100 still blank. The ocean reminds us that knowledge doesn't conquer mystery. It multiplies it. The more we learn, the more we realise how much remains beyond our reach. The machines extend our senses but not our comprehension. They tell us what is, not why. The questions remain suspended in the black water, waiting. And still, somewhere, in that darkness, another probe begins its descent. Its thrusters hum softly as it leaves the light behind. Instruments flicker to life. Cameras adjust to the absence of colour. It drifts through the cold, recording temperatures and currents. Its sensors tracing the unseen architecture of the world below. No one watches in real time. There's no live feed, no commentary. It moves alone, through silence so complete that even its own vibrations seem foreign. This is the purest form of exploration. Motion without witness, curiosity without audience. It's not the human body that explores anymore. It's the human intention, embodied in steel and algorithm, still searching, still dreaming. And as that machine disappears into the black, carrying with it the weight of our questions and the quiet persistence of our need to know, it becomes part of the story of the deep, a continuation of the long, slow descent into a world that will always remain just a little farther than we can reach. Every descent into the abyss eventually reaches a point where even our most sophisticated machines hesitate. It isn't marked by any visible line, no sudden change in colour or texture, no sign announcing that we've gone as far as we can. It's simply the limit, an invisible barrier where the ocean stops letting us continue. Sometimes it's mechanical, sometimes physical, sometimes something harder to define. The deeper we push, the clearer it becomes that the barrier isn't just around us. It's within us too. For all our progress, our vessels and sensors, our confidence in data, the deep still finds ways to remind us that there are boundaries we can't yet cross. It does so quietly, without resistance or malice, just by being what it is. A place too vast, too cold, too heavy, too quiet for us to ever truly belong. When we talk about exploration, we talk about breakthroughs, about technology overcoming nature. But down here, that story changes. The ocean doesn't yield, it absorbs. The more we try to push against it, the more it teaches us about restraint. At extreme depths, the physical limitations become immediate. The water pressure crushes anything with even a hint of weakness. Communication signals, already faint and delayed, vanish completely once a machine strays too far or an angle shifts the wrong way. A small error in navigation means drifting off course by hundreds of meters with no way to correct it. In the dark, there are no landmarks, no visual cues, no up or down, only data streams that may or may not be accurate. And when those fail, there's only the hum of machinery surrounded by silence dense enough to feel like substance. For humans on the surface, this barrier appears as uncertainty. We never quite know what's happening below, even when our instruments are working perfectly. The ocean filters and distorts every piece of information we collect. Sound waves bend through layers of varying temperature and salinity, creating echoes that mislead our sensors. Cameras limited by light show only fragments. Samples brought to the surface are altered by the very act of collection, their chemistry changed, their forms destroyed. The deep gives us data, but it never gives us context. What reaches us is an approximation, enough to spark theories, never enough to confirm them completely. It's tempting to think of this barrier as a problem to solve, a wall to break through. That's how human exploration has always worked. We build better tools, stronger materials, faster communication systems, and tell ourselves that eventually nothing will be beyond reach. But the abyss doesn't operate on the same terms. There's no shortcut through its silence, no technology that cancels out its laws of physics. The deeper we go, the slower everything becomes, until even progress feels like stillness. It's as if the ocean itself enforces patience. There are moments during deep-sea missions when the barrier makes itself known not through catastrophe, but through absence. The ROV's signal fades, the camera feed freezes, the sonar returns nothing but static. The machine drifts somewhere out of reach, continuing its mission alone, its lights glowing faintly in the dark until their energy fades. When contact is re-established, if it ever is, what comes back is often corrupted. Partial recordings, fragments of telemetry, a few seconds of video that stop without explanation. We're left to interpret the gaps. In a strange way, those empty moments feel as meaningful as the discoveries themselves. They remind us that even in an age of satellites and supercomputers, mystery still exists right beneath us. But the invisible barrier isn't just technological, it's biological. The human body was never meant to experience the deep directly. We've tried to simulate it in controlled environments, pressurizing chambers to study how our organs and cells react. The results are clear. At those pressures, nothing works properly. Proteins unfold, cell membranes rupture, gas bubbles form in bloodstreams and crush nerves. Even if we could somehow protect the body, the mind would falter. Darkness and isolation on such scales distort perception. Time loses meaning. Thought itself becomes heavy. No training, no preparation, no courage could undo that reality. That's why we rely on machines, to act as surrogates for senses that can't function here. Yet even they face their own version of fragility. Metal fatigues, circuits corrode, lubricants freeze. Every mission is a race against entropy. The deep doesn't fight back, but it erodes everything that enters it, dissolving the edges of our technology one microscopic failure at a time. Some of those failures are immediate and spectacular. Others are slow, invisible, building quietly over days until one joint, one seam, one forgotten gasket gives way. Down there, redundancy is survival, and even then, survival has limits. It's easy to romanticize the barrier, to imagine it as something noble, like a test of human spirit. But it's not dramatic. It's not an enemy or a gatekeeper. It's simply the shape of reality under extreme conditions. The ocean isn't trying to keep us out. It's just being itself. What feels like a wall to us is just equilibrium to it. That's what makes it both humbling and strangely beautiful. We're the ones who need permission, not it. Scientists and engineers often speak about this with a kind of quiet awe. They describe the way data becomes unreliable past certain depths, how sensors calibrated at the surface start to drift as pressure increases, how even the speed of sound shifts enough to make distances uncertain. They describe how robotic arms designed to move smoothly in one environment seize up in another, or how adhesives fail where heat and pressure conspire to separate them. Every failure tells a story. Every malfunction maps the edge of our knowledge. And then there are the more intangible barriers as the ones made not of metal or pressure, but of understanding. We can measure the temperature and composition of the water. We can photograph creatures that live without sunlight. But what we still can't grasp is how these systems persist, how they interact, how they fit into the greater ecology of the planet. The abyss doesn't lend itself to simple explanations. Its cycles are too long, its processes too slow. Some ecosystems in the deep operate on timescales of centuries. A whale carcass that falls to the seafloor might sustain entire communities of life for decades. A shift in ocean chemistry caused by climate change might take hundreds of years to reach equilibrium. Studying such systems is like trying to understand a sentence when you've only read one word. And even when we do learn something, there's always the haunting question of what that knowledge costs. Every probe that lands on the seafloor stirs up sediment that may take years to settle. Every sample taken is a life removed from a system that rarely sees disturbance. Exploration and interference are inseparable. The barrier we face isn't only technical or biological, it's ethical. How much can we study without altering what we're studying? How deep can curiosity go before it becomes intrusion? That question grows sharper as technology advances. We're reaching a point where mining companies are preparing to harvest minerals from the abyssal plains. Metals like cobalt, nickel and manganese, vital for renewable energy infrastructure, are found in abundance on the deep sea floor. The temptation is immense, a potential resource waiting in the dark, but the cost is equally immense. The sediments disturbed by mining could drift for thousands of kilometers, smothering fragile habitats, disrupting ecosystems that have existed undisturbed for millions of years. The life that thrives there does so under conditions we barely comprehend. Once destroyed, it may never return. The invisible barrier in this sense isn't something to cross. It's something to respect. Even our attempts to observe can be invasive. Bright lights scare away animals. Engine vibrations disrupt the natural soundscape. The chemical traces we leave behind linger far longer than we imagine. The abyss isn't empty space. It's a living system that notices every intrusion. For all our talk of discovery, most of what we do in the deep is interruption. The barrier reminds us of that every time we try to push farther. It doesn't need to fight us. It just waits for us to recognize the imbalance. There's a paradox hidden here. The very same distance that limits us also protects what lies below. Because it's so hard to reach, the abyss remains one of the last truly untouched places on Earth. That inaccessibility has become its shield. It's as if the ocean itself has built a defense mechanism, not consciously, but through the physics of its own existence. The pressure, the cold, the darkness. All of it conspires to preserve a kind of purity. The invisible barrier doesn't just stop us from entering, it stops us from ruining. In a sense, that might be the most important function of the barrier. It forces humility. It asks us to reconsider what exploration means in a world already mapped from orbit, a world where even the most remote mountains and deserts have been photographed and catalogued. The deep ocean remains the exception, not because it hides, but because it can't be reduced. It exists beyond convenience. That's why, despite all our machines, despite all our dreams, the abyss retains its mystery. It's not resisting us. It's preserving itself. There are times when the barrier feels almost conscious, when a submersible's systems begin to fail just as it nears a new depth record, when the current shifts suddenly, dragging a probe off course, when the video feed, flawless for hours, starts to distort into static the moment something unfamiliar appears on screen. Rationally, we know these are coincidences, technical quirks, physics behaving as physics does. But emotionally they feel like reminders. Every explorer feels them eventually. That moment when the deep seems to whisper, "That's far enough." It's not a warning, it's a boundary. And like all boundaries, it exists to be acknowledged, not broken. Sometimes, even at the surface, the barrier makes its presence known. Equipment recovered from deep dives often shows strange wear, as if aged decades in a few hours. The paint is stripped, the metals are pitted, the cables, though thick and strong, seem frayed from within. The deep doesn't rage, it erodes. Slowly, inevitably, it transforms whatever touches it. You can polish and repair the damage, but something in the metal always remembers. It's as though the ocean leaves its signature behind, a quiet message written in corrosion and fatigue. You don't belong here, but thank you for visiting. That's perhaps the real nature of the invisible barrier, not a wall to breach, but a boundary of belonging. The abyss allows us to look, to study, even to touch, but not to stay. The conditions that define it also exclude us, and maybe that's for the best, because if we could live there, if we could move freely through that darkness, it might not remain what it is. Our presence changes everything, always has. The barrier protects both sides, us from the pressure and the deep from our interference. As exploration continues, that understanding becomes more important. The machines we send down are improving, growing more autonomous, more precise, but they're also being designed with respect in mind. Engineers now talk about non-invasive exploration, about tools that observe without disturbing, robots that glide silently through the dark without light or sound, gathering data through touch, chemistry, and magnetism. The goal isn't conquest anymore, it's coexistence. The barrier has taught us that survival in the abyss means harmony, not dominance. And still, the mystery persists. We don't know what lies beyond the limits we can reach. There may be life forms unlike anything we've ever imagined, microbial, mechanical, or something stranger. There may be geological processes that rewrite what we know about the planet's evolution. There may be nothing but endless plain. The truth is, we don't know. The invisible barrier stands between our curiosity and the ocean's indifference, between what we hope to find and what we can actually grasp. And maybe that's why we keep returning. The barrier isn't a failure, it's an invitation, not to cross, but to question why we want to. If you linger on that thought long enough, the idea of limitation starts to feel less like frustration and more like balance. The abyss, with all its silence and weight, doesn't need to be conquered. It only needs to be understood from a respectful distance. The machines will keep diving, the signals will keep flickering through miles of black water, and occasionally they'll return with something new. But between those moments of discovery, the invisible barrier remains, patient and unbroken, reminding us that even on our own planet, there are places meant only to be witnessed, not possessed. And as the latest submersible drifts upward, its lights dimming, its sensors quiet, the surface slowly draws near again. The water brightens by degrees, the pressure eases, and the weight of the world begins to lift. Above, sunlight glints on waves that have no idea what lies beneath them. The invisible barrier fades, unseen but unchanged, holding the deep in silence once more, waiting for the next descent and the next questioner to begin. When the light fades completely and the last traces of human noise disappear into the cold, the ocean reveals its oldest inhabitants. This is the realm that begins where everything else ends, the vast living expanse that moves quietly beneath the weight of the world. It isn't empty, as we once believed. It's alive in ways that seem to disregard every rule written by the sunlit world above. Down here, existence continues in forms that barely seem possible. Slow, patient, deliberate, adapted to the near-eternal stillness that defines the deep. Everywhere you look, the darkness moves, not quickly, not with violence or energy, but with the slow precision of life that has learned not to waste anything. Shapes drift through the blackness like half-formed thoughts. Some are barely visible, translucent as mist. Their bodies little more than outlines of light-sensitive tissue and floating membranes. Others glow faintly with bioluminescent pulses, tiny lanterns blinking across the void in patterns so intricate they could almost be a language. The light they emit isn't meant to be beautiful, though it often is. It's functional, evolved through necessity, to hunt, to mate, to distract, to survive. In this kingdom of shadows, everything eats and is eaten in a continuous, measured rhythm. There's no abundance, no waste. Energy is rare and every spark of it must count. The predators here don't chase, they wait. The prey doesn't flee. It hides in plain sight, adapting by becoming nearly invisible. Many creatures are transparent, their organs and bones reduced to jelly-like structures that float neutrally in the water. Some have lost their eyes entirely, their world no longer shaped by light but by vibration, by pressure, by chemical trails in the water. Others have eyes so large they look impossible, spherical orbs designed to catch even the faintest trace of bioluminescence from far away. Each species here seems to be an experiment in endurance. There are fish with mouths that can unhinge wider than their own bodies to swallow prey larger than themselves, because meals are rare and opportunities must never be missed. There are creatures whose stomachs expand like balloons, whose jaws fold and refold in grotesque precision. There are worms that glow to attract attention, and others that vanish entirely into the sediment, their presence betrayed only by the faint movement of a filament waving for nutrients. In the deep, nothing is wasted, not energy, not time, not light. For a long time, we thought these creatures were monsters. When the first deep-sea nets came back full of strange gelatinous bodies, scientists and sailors alike saw them as grotesque, unnatural, even demonic. But what looked like deformity was simply adaptation. The abyss doesn't reward symmetry or beauty. It rewards efficiency. A body that bends under pressure survives. A creature that glows briefly and disappears has an advantage. The kingdom of shadows doesn't play by our aesthetic rules. It doesn't care about elegance or fear. It just works. When cameras finally descended into this darkness, the footage they brought back defied expectations. There were living ribbons that moved like whispers, their bodies hundreds of meters long and thinner than a rope. There were translucent spheres pulsing gently within a light. There were fish with heads that were half jaw, half lantern. There were crustaceans with limbs so delicate they seemed spun from glass. Some creatures looked ancient, like fossils that had never stopped breathing. Others looked newly imagined, as though evolution had kept experimenting in silence long after the rest of the world stopped watching. Even microorganisms down here have evolved into forms unlike anything at the surface. The bacteria that coat hydrothermal vents, for instance, thrive in conditions that would kill anything else. Temperatures above boiling, pressures hundreds of times greater than atmospheric, chemical environments saturated with sulfur and methane. Yet they flourish, forming the base of ecosystems so independent they might as well exist on another planet. Around these vents live giant tube worms, clams the size of footballs, and crabs that scuttle across scalding rock as though it were sand. None of these creatures rely on sunlight. Instead, they depend on chemosynthesis, life powered by chemical reactions, turning the Earth's internal heat into energy. It's strange to think that some of the most vibrant ecosystems on our planet exist in complete darkness. Down here, the idea of day and night means nothing. Seasons don't change. Temperature barely varies. There are no tides to mark time, no weather to alter the rhythm. Life proceeds according to its own quiet schedule, defined by the slow rain of organic material from above, the marine snow that drifts down endlessly from the dying remains of the upper ocean. When a whale dies at the surface, its body eventually sinks to the abyssal plain, becoming an island of abundance in an otherwise barren desert. Entire communities form around the carcass. Scavengers arrive first, hagfish, amphipods, ghostly eels. Then come worms that feed on the bones, and finally bacteria that break everything down to its elemental forms. What was once a living creature becomes the foundation for hundreds of others. Nothing is lost. The abyss has no waste, only transformation. This quiet cycle continues without pause, unseen, uninterrupted, and almost entirely unaffected by what happens above. The creatures of the deep have no awareness of the world of light. The concept of surface, of air, of stars, it doesn't exist for them. Their senses are tuned to subtler cues, the pulse of a current, the faint chemical trace of food drifting through the water, the low-frequency vibrations of something moving far away. In the absence of sight, they live by listening, by feeling, by detecting. To them, the ocean is not empty, but full of information. Every molecule carries a message. The strangeness of this world isn't just biological, it's atmospheric. The water here feels different, thicker, slower, almost alive with suspended particles that never settle. If you were to watch a submersible's lights moving through it, you'd see the beams scattering into haze, catching thousands of tiny motes drifting like dust in a sunbeam. Except there is no sun. The glow comes from the machine itself, from the artificial intrusion of our presence. Turn off the lights, and everything vanishes. The creatures fade, the particles become invisible, the world ceases to exist to our eyes, though it continues undisturbed, indifferent to our seeing or not seeing. In that invisibility lies a kind of peace. The deep doesn't need light to affirm its existence. It simply is. Every organism here has adapted to the certainty of darkness. Some species, when brought to the surface, die not from pressure but from light exposure. The sudden brightness burns their tissues, blinds them, overwhelms their delicate chemistry. It's as if the kingdom below has evolved to reject revelation. The darkness protects it, the silence sustains it, and silence here doesn't mean absence of sound. It means something closer to stillness. The deep has its own acoustics, low rumbles, faint clicks, the occasional crack of rock shifting miles away. Many of these sounds travel for hundreds of kilometers, distorted by layers of water that bend them in strange ways. Whales communicate through these depths, their songs stretching across oceans. Submersibles pick up the echoes of distant storms transmitted through the seafloor. Sometimes instruments record noises that have no identifiable source. Rhythmic pulses, metallic groans, tones that rise and fall like breathing. We call them unexplained because we can't find the cause, but to the creatures living here, they're probably just part of the landscape. The abyss has its own weather, and its weather is made of sound. Listening to those recordings can be disorienting. There's no rhythm to hold on to, no pattern familiar to the human ear. It's not music, but it has structure. Some scientists describe it as the voice of the ocean itself, not metaphorically, but literally, the sum of all the vibrations created by life, movement, and geological activity. When you listen long enough, you start to hear something that feels like presence. The silence of the abyss isn't empty. It's alive with faint, patient signals that never reach the surface. That's perhaps the hardest thing to grasp about this kingdom, how much of it exists beyond our senses. Even when we send cameras and microphones, what we capture is only the narrowest sliver of its reality. The creatures we see represent a fraction of what's out there. Most of the life here is microbial, bacteria, archaea, and other organisms too small to perceive directly. They live in the sediment, in the pores of rocks, in the water itself. Together they form a biomass greater than all the fish and whales combined. It's a hidden majority, working quietly to recycle the elements of life. Without them, the ocean's chemistry would collapse. Without them, even the world above would change. The deep is not a void, it's a foundation. And yet, despite its immensity, it remains fragile. The balance that sustains it can be disrupted by things that seem insignificant to us. A rise in temperature by a fraction of a degree, a change in oxygen concentration, a pulse of chemical runoff that travels down from the surface. The creatures here have evolved to survive extremes of pressure and darkness, but not the rapid changes brought by us. Pollution, noise, heat, they travel farther than we think. Even in the most remote trenches, scientists have found traces of microplastics and industrial chemicals. We've managed to leave our fingerprints in the one place we've barely touched. The kingdom of shadows is no longer completely untouched. Still, life endures. It adapts quietly, invisibly. Evolution never stops, even here. Some organisms now incorporate microplastics into their bodies as though they were part of the environment. Others shift their feeding patterns to account for changing currents. The abyss doesn't resist change, it absorbs it, the same way it absorbs everything else. But that absorption has limits. The deep can hide our waste, but it can't erase it. It's a lesson we haven't fully learned yet. The more we discover about this realm, the more we realize that it mirrors us in ways that are uncomfortable. The creatures that glow softly in the dark are reminders of our own small lights flickering against the void. The patience of the abyssal plane mirrors our own waiting for meaning in the vastness of time. The silence of this world echoes the spaces in our own minds where understanding ends and imagination begins. The kingdom of shadows and silence isn't just a place on Earth. It's also a reflection of something within us, the part that thrives in uncertainty, that exists quietly beneath the noise of thought. If you could drift here long enough, without sound or light, you might start to feel that connection. The darkness wouldn't seem empty anymore. It would feel full of life, of motion, of stories unfolding too slowly for any single lifetime to follow. The flicker of a distant light wouldn't just be a creature hunting, it would be a heartbeat. The faint rumble in the distance wouldn't just be a tectonic shift, it would be breath. Everything down here moves with purpose, even if that purpose is beyond our comprehension. And while the world above continues to change, racing through decades of noise and invention, the deep continues at its own pace, unhurried, unmoved. Its silence isn't indifference, it's endurance. The creatures here aren't waiting for us to find them. They're simply continuing, as they always have, under the same slow rhythm that predates humanity and will outlast it. The kingdom of shadows and silence doesn't seek acknowledgement. It doesn't need to. It exists perfectly as it is, self-contained, vast and indifferent to whether anyone ever sees it again. And somewhere within that endless dark where pressure and time converge into stillness, another small light appears, a drifting pulse from a creature or a machine, impossible to tell from a distance. It hovers briefly, then fades. The deep accepts it without question, as it has accepted everything else. Life continues, quiet and complete, beneath the world that forgets it's there. When we look into the deep, what we receive in return isn't silence. It only seems that way at first. The ocean is constantly speaking, though not in a language made of words or light. Its messages come in vibrations, in data, in fragments of sound that take patience to interpret. The deeper you listen, the more you realize the abyss has always been communicating. It just doesn't care if anyone is listening. Every echo, every pressure wave, every fluctuation in current is part of a constant exchange between the Earth and itself, a conversation that has been happening since long before we arrived. When scientists talk about studying the deep, what they often mean is listening to it. Light fades too quickly, cameras fail, and even the strongest machines can only capture narrow glimpses of the vastness below. But sound travels far. It moves through the water with a clarity that defies its density. Whales have known this for millions of years. They send low-frequency calls that cross entire oceans, each note travelling for thousands of kilometres without losing form. The ocean, in that sense, is an enormous instrument, one that hums with constant overlapping vibrations from both living and geological sources. To make sense of these messages, we deploy networks of hydrophones, underwater microphones anchored to the seafloor or suspended from drifting buoys. They record continuously, day and night, over years, capturing everything from the faint crackle of icebergs breaking apart in the polar seas to the rhythmic clicking of deep-diving sperm whales as they hunt. Sometimes, amid all that sound, something unfamiliar appears, a series of tones that don't match any known pattern, a pulse too regular to be random, a noise that repeats but never quite resolves. Scientists call these unidentified biological sounds, a deliberately cautious phrase that means, in simple terms, something is making noise down there and we don't know what it is. One of the most famous of these unexplained sounds was recorded in 1997. It came from somewhere near the Pacific Antarctic Ridge, a region of seafloor where tectonic plates shift and molten rock occasionally breaches through. The sound was deep, resonant, and powerful enough to be picked up by sensors over 5,000 kilometers apart. It rose in pitch over a minute, almost like the sound of something enormous stirring. It was nicknamed the bloop. For years it inspired speculation. Some thought it might be the call of an unknown animal larger than any whale. Others suggested volcanic activity, shifting ice, or even mechanical interference. Eventually the consensus settled on the simplest explanation: the sound of icebergs fracturing and scraping against the seafloor. But even that doesn't fully explain its structure. It remains one of the ocean's quieter riddles, not a mystery that demands solving, but one that reminds us of how much remains unheard. These are the kinds of messages we get from the black. Not revelations, but hints. The deep doesn't tell stories the way we do. It offers pieces, and it's up to us to assemble meaning from them. Hydrophones record the collapse of distant landslides, the groans of submarine ridges, the faint whisper of underwater currents shifting over centuries. The Earth's crust itself speaks in frequencies too low for human ears, vibrations that trace the movement of magma, the spreading of oceanic plates, the heartbeat of the planet's internal machinery. When you compress those recordings and play them back at normal speed, the deep sounds alive, not metaphorically, but physically, pulsing, resonating, breathing. And woven among those geological sounds are the voices of life, the clicks of dolphins navigating the upper depths, the long plaintive moans of blue whales echoing through twilight layers, the rapid-fire pops of snapping shrimp that create entire fields of underwater crackle, loud enough to mask other noises. Each species contributes to the soundscape, shaping it into a living chorus. Even microorganisms generate noise, the fizz of gases they release, the faint vibrations of their movements. The result is something like a symphony without conductor or audience, chaotic and yet perfectly balanced. To study this symphony, researchers use spectrograms, visual representations of sound where frequency and time form a kind of landscape. On these graphs, the ocean becomes a tapestry of colour and rhythm. You can see whale calls as long sweeping arcs, volcanic rumbles as deep bands, sonar pings as sharp vertical lines. But even after decades of study, there are patterns no one can explain. Some repeat seasonally, others appear once and never again. It's as if the deep sends signals on its own schedule, indifferent to whether we catch them. The most patient scientists know this. In the abyss, meaning comes slowly, if at all. Our machines too add their own voices to this environment. Every propeller, every thruster, every sonar pulse contributes noise that spreads for kilometers. The ocean is sensitive to it. Animals that rely on sound for navigation and communication are often disrupted by human noise. Shipping, drilling, seismic surveys. To us it's background hum. To them it's thunder. In recent years, researchers have begun to talk about acoustic pollution, the idea that our presence is altering not just the physical, but the auditory landscape of the deep. We are changing the sound of the ocean, layering our frequencies over those of the creatures who have used it as their medium for millennia. The irony is that we began by listening and ended up drowning out what we came to hear. The hydrophones that once recorded the songs of whales now pick up the engines of cargo ships. The clicks and calls that once mapped the ocean's natural rhythms are now overlaid with the mechanical heartbeat of human commerce. Yet, even through that interference, life persists. The whales adjust their tones, shifting to lower frequencies to avoid our noise. The fish adapt their spawning calls to narrower windows of silence. The deep absorbs even our mistakes and carries on. Still, there are moments when listening brings back something pure. In 2015, scientists recorded a strange, haunting sound from the Mariana Trench, a series of low pulses that rose into a high-pitched crescendo, then faded abruptly. It repeated at dawn and dusk, leading researchers to suspect it was biological. Years later, it was identified as the call of a previously unknown species of baleen whale. Its frequency was unlike any other. It had been there all along, speaking in a voice that simply hadn't been heard. That discovery was more than just a new data point. It was proof that even in the age of constant observation, the world can still surprise us. Listening to the abyss isn't just about discovery, though. It's also about humility. Every sound carries information about a world where we are outsiders. Each echo that returns to our instruments has travelled through water that compresses, bends, and transforms it. What we receive isn't a perfect reflection, but a translation, distorted by distance and density. The ocean speaks in echoes, and we spend our lives trying to decipher them. That process feels almost philosophical, a meditation on how little we can ever know directly. Beyond sound, there are other kinds of messages that reach us from the black. Chemical signals drift through the water, traces of life and decay that scientists can detect in microscopic concentrations. By analysing these compounds, we can infer what kinds of organisms live nearby, what they eat, how they reproduce. It's like reading the ocean's diary, written not in words but in molecules. In recent years, advances in environmental DNA, eDNA, have made it possible to identify species without seeing them at all. A few litres of seawater can contain genetic fragments from thousands of organisms. Filtering that water and sequencing its contents reveals a map of invisible life. Through these genetic echoes, we've discovered species that have never been photographed or captured. The deep leaves its fingerprints everywhere, if you know how to look. But even these fingerprints are fleeting. Currents mix and disperse them. Temperature gradients carry them upward or down, scattering their information like whispers in a storm. The deeper you go, the slower everything moves, but nothing ever stops. The abyss is in constant motion, its messages never fixed. That impermanence is both the beauty and the frustration of studying it. Every reading, every sample, every recording is a moment in time, a single page torn from a book whose ending we'll never read. And yet, we keep listening. There's something addictive about the unknown signals, the mysterious frequencies, the quiet reminders that the world is still larger than our understanding. Each new anomaly reignites a sense of wonder that modern science sometimes forgets. The idea that somewhere, miles below, something is moving, calling, existing, unseen, unnamed, unrecorded, is enough to keep people building better instruments, better sensors, better algorithms. We chase those signals not because we expect answers, but because they remind us that there's still mystery in the world. Sometimes the messages aren't even meant for us, but we intercept them anyway. Whales and dolphins use frequencies that overlap with sonar and communications equipment. Their calls bleed into our recordings, and our signals bleed into theirs. The result is a strange, unintended dialogue, one species talking through machines, another replying through instinct. There have been instances where whales followed ROVs for hours, circling them, emitting calls as if curious about the new voice in their world. Maybe they recognise something alive in the mechanical hum. Or maybe they were simply investigating a new sound. Either way, it's communication across a divide that neither side fully understands. The more we learn about the deep, the more we realise that listening is a form of coexistence. It doesn't require domination or control, only patience. It's an act of respect, to hear without interrupting, to observe without intruding. The abyss doesn't need our attention to exist, but when we listen properly, we become part of its rhythm for a moment. The machines that record its sounds, the scientists who study them, the listeners who hear them, all of them become temporary participants in the long conversation of the sea. Sometimes the messages from the black are simple data streams, temperature readings, salinity profiles, current velocities. Other times, they are profound. Seismic waves that reveal the structure of the Earth's mantle, traces of methane hinting at potential life near hydrothermal vents, chemical shifts that foreshadow global climate changes decades before they appear on the surface. The abyss doesn't just hold secrets about itself. It holds the memory of the planet, recorded in pressure, chemistry and time. Every sample drawn from those depths carries history. Ancient carbon, microscopic fossils, minerals shaped under conditions no human could survive. When we study them, we're reading chapters written in water and stone. And every so often, amid all that information, something unexplainable appears. A signal that doesn't match any known biological or geological pattern. A blip on a sonar map that moves when nothing should. A faint electrical disturbance in water thought to be inert. We label these as anomalies and move on, but they stay in the back of the mind. Maybe they're errors. Maybe they're something we haven't learned to name yet. The ocean doesn't reveal all its messages at once. Some require decades to understand. Some may never be meant for us at all. In the end, the act of listening becomes less about discovery and more about relationship. The abyss speaks in its own time, in its own language. We respond with curiosity, with patience, with the quiet acknowledgement that our role is not to command but to translate. The messages we receive, the sounds, the data, the fleeting glimpses of bioluminescent movement, are not invitations to conquer. They're reminders that we're part of a larger conversation happening all the time, one that began long before we were here and will continue long after. And as another array of hydrophones settles into the deep, its instruments blinking faintly before being swallowed by darkness, the listening begins again. Somewhere below, something moves, something calls, something vibrates through the endless black water. The signals travel upward, distorted but intact, until they reach a receiver on a ship or a station or a computer screen. Another message, another mystery, another echo from the heart of the world. The deeper our machines travel, the more we begin to learn that the abyss does not surrender easily. It doesn't resist in the way a living creature might, with hostility or aggression. It resists by being what it is, a place where everything human begins to unravel. The ocean doesn't fight back with intention. It simply waits, and in that waiting, it wins. Pressure, corrosion, distance, time. They are its silent defenders. Every descent becomes a quiet confrontation with limits we prefer not to acknowledge. It's easy to think of the abyss as passive, a cold expanse of darkness where nothing happens unless we arrive to observe it. But that illusion disappears once you start sending machines into it. The deep is not still. It's active, shifting, and constantly testing whatever enters it. The first time engineers lowered steel spheres into the trench waters, they heard the metal pop and groan like something alive. Each sound was a reminder that even the strongest materials have breaking points. The water presses evenly from all sides, and when it finds a weakness, a hairline crack, a tiny imperfection in the weld, it doesn't exploit it instantly. It waits until the moment of greatest confidence, when the descent seems smooth and stable, and then the failure comes without warning. There are stories of submersibles lost without a trace, machines that vanished during descent, their cables snapping, their lights flickering out before contact was lost entirely. Some were found years later, buried in sediment, Others never recovered. At depths of 6 or 7 miles, recovery is nearly impossible. The weight of the ocean closes around wreckage like a fist, erasing every sign of intrusion. It's not vengeance, just gravity and density doing what they've always done. Down there, failure doesn't echo, it dissolves. Even the technology that survives doesn't return unchanged. When a submersible surfaces after a long dive, the wear is visible. Paint stripped away by friction, bolts bent, cables swollen from internal stress. Glass viewports sometimes appear flawless until light catches them at the right angle, revealing spiderweb cracks too fine to notice but fatal if pressed again. Engineers call it pressure memory, the way materials seem to retain the experience of what they've endured. You can repair, polish, reinforce, but that memory lingers, invisible fatigue waiting for its next test. The abyss, in this way, leaves marks on everything that touches it, a slow reminder that survival here is temporary. But not all of the ocean's resistance is mechanical. It's chemical too. The deeper you go, the more corrosive the environment becomes. Salts, minerals, and dissolved gases combine to attack even the most resilient alloys. Titanium darkens, copper tarnishes, plastic hardens and fractures under cold and pressure. Some deep-sea probes designed to last years stop functioning after months because the water has found its way into joints and seals that were supposedly impenetrable. The ocean infiltrates not by force, but by persistence. It's patient in ways we aren't. It waits for us to assume control, then reminds us that control is an illusion. Every explorer who's worked with these machines knows the feeling. You plan for months, test every system, check every line of code, every bolt, every gasket. You deploy. Everything goes smoothly for hours, then one light flickers, one reading turns strange, one command fails to send. In the silence of the deep, that single failure expands. You wait for a signal that never returns. The crew sits in stillness, eyes fixed on monitors showing static. The ocean doesn't explain itself. You retrieve what you can, sometimes fragments, sometimes nothing. You study the data afterward, searching for the cause, but the abyss leaves no clues. What's gone stays gone. It isn't only our machines that suffer. Even our understanding is constantly undone. We build models of how the deep should behave, how its currents move, how its chemistry changes. Then the data returns and breaks those models. Temperatures are different. Sediment flows where it shouldn't. Creatures appear where none should survive. Every time we think we've mapped the rules, the abyss rewrites them. It doesn't defy science. It refines it by humbling it. We approach with equations and leave with questions. That's its quiet rebellion. It doesn't destroy, it corrects. In the mid-20th century, when deep-sea exploration was in its infancy, there was a belief that once we developed the right materials, the right vessels, the ocean would eventually yield to us the way mountains had. But the first dives proved otherwise. The pressure didn't just threaten the equipment, it threatened comprehension itself. Instruments failed not because they were weak, but because the environment was incompatible with precision. Even timekeeping became unreliable. Clocks slowed, sensors drifted, and readings contradicted one another. The abyss refuses consistency. It changes subtly, invisibly across depths and regions. What works perfectly in one trench fails completely in another. That unpredictability extends to the living world as well. Life in the deep doesn't follow the patterns we know. Some species vanish entirely for decades, then reappear in abundance without reason. Others migrate vertically, rising thousands of meters every night in the planet's largest unobserved migration, then descending again before dawn. Scientists call this the Deal vertical migration, an enormous movement of biomass that shapes the entire ocean's food web, and yet we still don't fully understand why it happens or what signals trigger it. The abyss keeps its timing to itself. Every time we attempt to impose order on it, something pushes back. Not violently, but definitively. A robotic arm refuses to function. A cable tangles, a light fails. These aren't random malfunctions. They're reminders of how easily our technology breaks when removed from the context it was built for. The deeper we go, the more everything designed by human hands becomes brittle, not only physically, but conceptually. We are builders of systems that rely on predictability, and the abyss is a place that erases patterns. That's why, even after decades of exploration, much of what we know about it remains descriptive rather than explanatory. We can list its features, but not its logic. There's a psychological dimension to this resistance too. Those who've spent time studying the deep often describe an unease that's hard to define. It isn't fear of danger, it's a sense of being unwelcome, or rather, of being irrelevant. The ocean doesn't acknowledge you. Its vastness is so complete that your presence feels like an interruption. The longer you stare into that darkness, the more it feels like the darkness is staring back, not with hostility but with indifference. That indifference is harder to face than hostility. When nature fights back through storms or quakes, we understand it. But the deep's form of resistance is silence. It erases our efforts through stillness. You leave, and it closes as if you were never there. There have been expeditions where entire projects vanished into that silence. Instruments lowered for data collection simply stopped transmitting. Months later, when retrieved, they showed no sign of damage, no visible flaw. The failure remained unexplained. The ocean's chemistry sometimes plays tricks like that. Small electrical currents induced by moving water can interfere with communication lines, producing false readings or total loss of signal. Even today, with all our advancements, these inexplicable disruptions persist. We design redundancies, backups, fail-safes, but the abyss continues to find ways around them. It's as though every descent is a conversation, and the deep has learned the art of selective response. The ocean also pushes back in more subtle ways. Its immense pressure makes data expensive to gather. Each sample or image requires immense energy, and that energy must come from somewhere. Submersibles carry limited batteries, and the deeper they go, the more power is consumed just maintaining equilibrium. As a result, every observation has a time limit. When that time runs out, the machine must rise, leaving whatever mysteries remain below unresolved. The abyss knows patience. We don't. Sometimes it responds in ways that remind us of scale. During one deep-sea deployment in the Pacific, researchers sent an autonomous probe to monitor hydrothermal vents. For months, it transmitted readings of temperature, salinity, and mineral output. Then one day the data changed abruptly. The readings spiked, then went silent. When the probe was recovered, its casing was covered in hardened mineral deposits. The vent it had been studying had erupted, engulfing it in newly formed crust. The machine had become part of the sea floor. What began as observation ended as absorption. The abyss doesn't discard what it takes, it incorporates it. That tendency extends beyond individual machines. The history of exploration is littered with wrecks. Submersibles, drones, research instruments, even entire ships that sank during storms. All of them end up in the same place eventually, settling into the deep, swallowed by sediment. There's a quiet irony in that. The tools we send to study the abyss inevitably become artifacts within it. Future explorers may one day find our technology the way we find whale bones, relics of curiosity slowly colonized by leaf. The deep turns everything into part of its story. Even when we succeed, it feels temporary. Cameras capture astonishing images, alien creatures drifting through black water, vents glowing with mineral light, landscapes that look more like distant planets than parts of Earth. But the moment the lights go off, those scenes vanish completely. The ocean reclaims its opacity. Our footage may circulate online, our discoveries celebrated, but down below, nothing has changed. The abyss absorbs the intrusion and resets. It's a resistance born of infinite patience. What makes this resistance profound is that it isn't malicious. The ocean doesn't hate us. It simply continues, unaffected by our intentions. We build machines to endure its pressure. It teaches us pressure is everywhere. We build sensors to record its silence. It reminds us silence can't be measured. Every attempt to define it ends up defining us instead. We learn more about human limitation than about the deep itself. It's as though the abyss reflects our persistence back to us in distorted form, showing us both the power and futility of our need to know. That's why, when people talk about the deep as an adversary, they misunderstand it. It doesn't fight back in defense. It doesn't need to. Its power lies in permanence. It has no interest in victory because it has no sense of threat. The abyss doesn't compete. It endures. Its resistance isn't a battle, but a boundary, one that shifts only when we learn to approach differently. The lesson isn't how to conquer, but how to coexist. And yet, we keep testing it. Every generation of explorers builds something stronger, lighter, smarter, hoping this time the deep will cooperate. And each time, it teaches the same lesson in a new way. Cable snaps. A circuit fails. A camera captures something unexpected that rewrites what we thought we knew. It's not failure, it's feedback. The abyss doesn't reject us. It calibrates us. It pushes back just enough to make us change our approach, forcing us to become more careful, more precise, more respectful. It's a dialogue written in pressure and persistence. There's something strangely comforting in that. We need the abyss to fight back. Without its resistance, exploration would be easy, and easy things don't teach much. The ocean's refusal to yield keeps us honest. It prevents arrogance from hardening into certainty. Every failure at depth is a reminder that understanding comes through humility. The more the abyss resists, the more we learn, not just about it, but about the limits of our own comprehension. When you listen to scientists who've spent their lives studying the deep, you notice that their language becomes almost reverent. They don't speak about victory, they speak about permission. Each successful mission feels like something granted, not achieved. Each discovery feels borrowed, temporary. It's as if the abyss allows us brief moments of clarity before closing again. And in that rhythm, approach, observe, retreat, repeat. Something like respect begins to form. The ocean doesn't need to defend itself with force. Its power lies in indifference. And yet, that indifference has a strange generosity to it. It lets us touch the edges of what we can't comprehend, just long enough to remind us that curiosity is worth the risk. Every time we lose a machine, every time we fail to recover data, every time the deep reclaims what we send, we're reminded that some mysteries endure precisely because they must. The abyss fights back not to keep us out, but to keep itself whole. And as another vessel begins its slow descent, as lights dim and pressure builds and the ocean folds around it, the deep waits. Not as an enemy, not as a host, but as what it has always been. The patient, silent counterweight to everything above. What we call resistance is, to it, simply balance. There's a moment during every descent when the lights fade and the instruments hum quietly, when the world above disappears so completely that the mind begins to drift. It's then, in that calm suspension between movement and stillness, that the ocean begins to feel like a dream, not one made of fantasy, but of something older and deeper, something that remembers long before we existed. The deeper you go, the more that sensation takes hold. The abyss becomes less like a place and more like an idea, a frontier without borders, where time loosens and the boundaries between what's alive, mechanical and imagined start to blur. The explorers who spend their lives studying these depths often describe it in strangely emotional terms. They talk about a kind of detachment that feels peaceful, not fearful. They say that the longer you stare into the black water, the more it starts to feel familiar, not because it's welcoming, but because it's honest. There's no pretense here, no illusion of control or progress, just existence, slow and steady, continuing as it always has. It's a frontier not of conquest, but of endurance. The dream of the abyss isn't about discovery, it's about presence. When we think of frontiers, we tend to imagine landscapes, mountains to climb, planets to reach, territories to map. But this one has no surface, no horizon. It's an expanse that swallows direction itself. Down here, forward and back lose meaning. There's only descent and drift. The ocean doesn't define its boundaries the way land does. They shift constantly, redrawn by currents, pressure and time. And yet, within that formlessness there's structure, unseen systems of flow and temperature that shape everything. The dreamlike quality of the abyss isn't chaos. It's order too vast and slow for us to perceive in real time. The frontiers of the past were places where humans could leave footprints. This one erases them instantly. The silt at the seafloor records no memory of our passing. Machines land, stir the sediment, and within minutes the marks are gone, covered by the slow rain of particles drifting endlessly from above. It's as if the deep refuses to be documented. Every image, every measurement, every map is temporary. Even the data degrades over time. The abyss is an archive that cannot be owned. That impermanence has its own kind of beauty. In a world obsessed with permanence and progress, the deep offers a rare stillness, not emptiness but continuity. Everything here moves, but nothing rushes. It's a place where evolution forgot urgency. Species remain unchanged for millions of years because they've already perfected survival. Their pace of existence is measured not in generations but in geological epochs. Some fish lay eggs that take months to hatch. Some worms grow so slowly that their lifespans may rival entire civilizations. When we observe them, we're not witnessing moments. We're glimpsing entire timelines condensed into gestures. The longer you watch the abyss, the more the distinction between life and environment starts to blur. Creatures and landscape merge into one continuous system. The glowing forms that drift through the water seem like extensions of the ocean's own body. The vents that pour mineral-rich plumes into the darkness resemble breathing. The movements of currents feel almost sentient, not because they think, but because they remember. The deep isn't passive. It reacts, adjusts, recalibrates. Every current, every tremor, every shimmer of light has purpose, even if that purpose lies beyond what we can measure. It's no wonder some explorers speak of the deep in language that sounds spiritual, even if they mean it scientifically. The abyss evokes reverence, not because it's mysterious, but because it's complete. There's nothing missing here, nothing in need of improvement. The ecosystems are closed loops, perfectly balanced within their own parameters. The hydrothermal vents create their own sunlight through chemistry. The creatures that feed there thrive without ever seeing the sky. When you witness that self-contained precision, it feels less like observation and more like revelation, not of divinity, but of design stripped of ego. The frontier of the abyss isn't waiting for us to cross it. It's waiting for us to understand what kind of frontier it actually is. We're used to frontiers being boundaries that yield when pressure is applied. The deep is different. It's a frontier that endures by not changing. To explore it means learning to slow down, to observe without forcing. The dream of a sunless frontier isn't one of expansion, but of humility, the recognition that some places are already complete without our participation. For centuries, humans imagined the ocean's depths as places of terror, filled with monsters and chaos. The unknown was always painted as hostile, but as we've learned more, that fear has softened into awe. The monsters turned out to be creatures of grace and function, the chaos a form of equilibrium we hadn't recognized. The abyss didn't need to be conquered because it was never an opponent. It was a teacher, one that communicates in patience rather than spectacle. That patience has influenced the way we think about exploration itself. The The frontier now is not about distance, but about comprehension. It's about learning to coexist with something that doesn't respond to our usual methods. Machines don't bring back conquest, they bring back perspective. Each dive reveals not how much there is to take, but how little there is to control. Every descent is a lesson in smallness, in the recognition that our most advanced technologies remain fragile against the scale of natural systems that have existed unchanged for eons. The deeper our understanding grows, the more we see parallels between the abyss and the rest of the universe. Space and the deep sea are mirror realms, both silent, both indifferent, both shaped by extremes. Yet there's a subtle difference. Space expands, the ocean compresses. Space draws things apart, the ocean pulls them inward. One is a void that invites movement, the other is a weight that invites stillness. Both represent limits of human endurance, and both force us to confront the same truth, that the unknown doesn't exist for our discovery, but for its own existence. If you think about it long enough, the deep starts to feel like the subconscious of the planet, a realm of dreams that never reaches the surface, a memory system older than any forest or mountain range. The sediments record not events, but eons. Layers of dust and organic debris build up centimetre by centimetre, compressing time itself into a kind of physical memory. If you could read those layers like pages, you'd find not stories of creatures or empires, but of climates and currents, of chemistry and motion. The abyss remembers the planet in a way no living mind can. And in that memory there's still change. The ocean's slow breathing, its circulation of water from surface to depth and back again, is one of Earth's longest cycles, taking over 1,000 years to complete. A particle of water that sinks into the deep may not return to sunlight for 10 or 20 human generations. In that time, it will have witnessed volcanic eruptions, continental shifts, the births and extinctions of species. That's what makes the abyssal frontier feel timeless. It doesn't freeze time, it stretches it until it becomes almost infinite. When people talk about dreams of exploration, they usually mean imagination, the will to push boundaries. But the dreams that come from the deep are different. They aren't filled with action or discovery. They're slow, dense, almost meditative. They drift like the currents themselves, steady, quiet, full of presence. The deep doesn't invite adrenaline, it invites reflection. The machines that travel there operate at speeds measured in centimetres per second. Their cameras capture images so slowly that what looks like stillness often turns out to be motion too gradual for the eye to perceive. Watching that footage feels like watching the planet breathe in slow motion. And yet, despite that tranquility, there's something profoundly dynamic happening. The deep is constantly reshaping itself. Undersea ridges grow by millimetres each year. Sediment slides reshape the topography of valleys. Earthquakes rumble quietly beneath layers of water so thick they barely register on the surface. The dreamlike calm of the abyss hides constant movement, a balance of creation and erosion, of heat and pressure, of decay and renewal. The frontier may be sunless, but it's alive with transformation. In that sense, it's not just a dream we enter, it's a dream we're part of. Every river, every storm, every tide above feeds into it. The carbon we breathe, the heat we release, the waste we discard, all of it eventually reaches the deep. Our civilization has already left its shadow there. Microplastics, carbon sediments, traces of radiation. Our modern signature now lies alongside those of long-dead species and shifting continents. The sunless frontier has become a mirror, reflecting not just Earth's natural processes, but our presence in them. And yet, for all the impact we've had, we remain disconnected from it emotionally. The deep feels distant because it refuses to participate in our sense of urgency. It doesn't react, it absorbs. While we measure time in seasons and economies, the abyss measures it in centuries. It's not hostile to change. but it doesn't hurry to accommodate it. That's why studying it feels so alien. We're used to systems that respond visibly, immediately. The deep answers only through patience. That patience can be unsettling. To confront it is to feel the weight of a world that doesn't need us. It's a reminder that the planet isn't fragile in the way we imagine. Ecosystems may collapse, species may vanish, climates may shift, but the Earth itself endures. The abyss has survived every extinction, every upheaval. Its dream has never stopped. Even when surface life was reduced to ruin, the deep remained alive, quietly cycling through its endless motions. That's the kind of resilience that defies human scale. Not strength, but continuity. Some researchers describe working with deep-sea data as an act of translation. The measurements, the images, the samples, they're fragments of a language that takes years to interpret. You can't force understanding, you can only accumulate it slowly. It's the same rhythm the abyss uses to think, if thinking can even be applied to such a system. Over time, the process begins to feel less like research and more like conversation. You learn to listen for patterns, to expect pauses that last longer than your attention span. You learn to respect silence as part of the answer. The dream of this frontier isn't about reaching the bottom. It's about realizing there may be no bottom to reach. The trenches descend into darkness until instruments fail, but even then, below the limits of our senses, the ocean continues. We've never truly reached the end of it, only the edge of what our tools can endure. The abyss doesn't stop where our measurements do. It keeps going, in pressure, in chemistry, in thought. It's possible that life does too. Perhaps the real dream isn't about discovery, but about perspective. Understanding that what we call exploration might actually be participation in a process that's been happening all along. Every descent, every machine, every signal we send is part of the ocean's ongoing story. We're not intruders in the abyss, we're latecomers. The dream was already in progress when we arrived, and it will continue long after we leave. And somewhere in that dream, beneath layers of pressure and shadow, another current begins to move. It doesn't rush, it doesn't announce itself, it simply flows, carrying with it traces of minerals, fragments of life, and echoes of everything that has ever fallen from the world above. The ocean breathes again, unhurried, eternal, carrying its memories forward into the darkness, where they'll drift for centuries before anyone notices they were there. There's a moment in every story of exploration when the question quietly changes. It starts with what can we find, then becomes how far can we go, and eventually turns into something softer, more hesitant. Should we be here at all? The deep ocean has a way of bringing that question to the surface, even though the surface is the one place it never belongs. The farther we push into the abyss, the more it begins to feel less like a discovery and more like an intrusion. It's not that the deep forbids us, it simply doesn't acknowledge us. This silence is not rejection, but indifference. And in that indifference lies a truth we rarely face. Maybe some places are not meant to be reached. It's difficult for humanity to accept that idea. Our history is built on reaching, on extending, on turning mystery into knowledge. We've walked on the moon, mapped distant galaxies, engineered machines to simulate the birth of the universe. We've made the impossible look routine. But the abyss doesn't respond to that same confidence. It's the last reminder that knowing isn't always belonging. We can measure the pressure, record the sound, analyze the data, but we still stand outside the system we study. The deep doesn't yield meaning the way we expect. It offers experience instead, one that resists interpretation. When explorers and engineers talk about the deep, they often describe it as something they participate in, not something they conquer. You don't enter it, you borrow it. You visit for a while if the machines allow, and then you leave it exactly as you found it. There's a humility in that exchange, the recognition that knowledge doesn't always come with control. The deeper you go, the more apparent it becomes that the ocean doesn't need to be understood to exist perfectly. It already knows what balance is. It already knows how to sustain life without interference. Our presence there is like a passing thought in a mind too vast to notice. Perhaps that's the hardest truth for us to face, that our curiosity, though noble, isn't always the right form of attention. The human desire to explore is rooted in the belief that everything can be mapped, explained, and catalogued. But the abyss doesn't reward explanation. It erases it. Every time we try to define it, the definitions collapse under pressure. Every certainty we build there fades the moment we leave. The deep doesn't change to accommodate our understanding. We change in the attempt to reach it. There's a certain quiet beauty in that futility. It means that wonder still exists, even in a world where so much has been seen, photographed, quantified. The abyss remains a space that refuses domestication. It's one of the few places left where mystery survives by design. Its depth, its darkness, its endless pressure. They are not obstacles but guardians. They protect something from us, or perhaps from the kind of thinking that insists everything must have a purpose within our frame of reference. Maybe the abyss isn't meant to be explored in the way we imagine. Maybe it exists precisely to remind us that not everything is meant for us. You can see that idea reflected in the creatures that live there. They've evolved in isolation, untouched by the ambitions of the surface. Their lives unfold in cycles so long and subtle that our attention spans can't hold them. They don't seek to leave their world or expand into ours. They exist entirely within the conditions they were born into. Their perfection lies in their containment. The deep doesn't need to reach upward because everything it needs is already within. It's humanity that's always reaching outward, trying to stretch beyond its natural boundaries, trying to fill silences that never asked to be filled. The more we send our machines into the deep, the clearer it becomes that the abyss doesn't belong to us, even in data. We may capture its shapes and measurements, but not its essence. We can describe pressure gradients and mineral compositions, but those details don't capture the experience of stillness or the sense of being surrounded by something vast enough to erase thought. Science can measure everything except meaning, and meaning is the one thing we keep searching for, even when it isn't offered. There's something almost human about that struggle. Our refusal to accept limits, our constant need to interpret everything through emotion and significance. We look at a bioluminescent creature drifting through darkness, and we call it beautiful, as though beauty were part of its intent. But it doesn't glow for us. Its light has purpose, but that purpose isn't meaning in the way we define it. It's survival. Everything down there functions without narrative, without symbolism, without drama. The abyss is pure existence stripped of interpretation. That's why it feels alien, and also why it feels sacred. It's the closest thing we have to seeing life outside the lens of human concern. Maybe that's what makes it so unsettling. It reminds us of a world that doesn't need us. For all our advancements, for all our confidence in technology, we remain dependent on a narrow range of comfort. Air, warmth, pressure, light. We live in a fragile equilibrium of conditions, and the abyss ignores all of them. It thrives where we cannot breathe, move, or survive. It's a reminder that life doesn't revolve around us, that the Earth's capacity for creation extends far beyond our comprehension. Some scientists have come to see the deep as a kind of mirror for our psychological boundaries. The further we descend, the more we confront not just the unknown, but the unknowable. It's not only a physical limit, as it's an existential one. The darkness becomes a metaphor for what we can't see within ourselves, for the questions that science can't translate into data. There's a reason the imagery of the abyss resonates so strongly in art and philosophy. It represents both the allure and the terror of facing something without edges, something that simply is. The temptation, of course, is to believe that if we keep improving our machines, we'll eventually overcome these limits. That technology can make the abyss accessible, perhaps even habitable, but accessibility isn't understanding. Even if we build vessels that can stay submerged for years, even if we map every trench in exquisite detail, we'll still be looking at the surface of a deeper mystery. There's no final layer to reach. Every boundary crossed only reveals another. The ocean, like time, like consciousness, is infinite, not because it never ends, but because our perspective never can. It's possible that our role is not to conquer these places, but to learn from them. The abyss teaches by withholding. Its silence forces patience. Its pressure teaches respect. Its indifference humbles us. In every failed expedition, in every lost machine, there's a lesson about scale, about proportion, about knowing when to stop. We often treat exploration as a story of achievement, but maybe it's also a story of restraint, of learning to listen rather than to demand. If the deep seems inaccessible, it might not be because we lack the tools, but because we misunderstand the invitation. The ocean doesn't call to us as a challenge. It calls as a reminder of balance. Its existence says, this is how the world persists without interference. Every current, every organism, every chemical exchange functions in harmony, not because it's designed that way, but because it has evolved through endless cycles of trial and adjustment. We could spend another 1,000 years studying it and still only glimpse a fraction of its complexity. That's not a failure of science, it's a reflection of truth. Some systems are too complete to be simplified. Even the idea of discovering something new in the abyss carries a kind of arrogance. Whatever we find down there, a new species, a new mineral formation, a new chemical process, has existed for eons. We didn't create it. We only noticed it. Discovery is just recognition delayed. The deep doesn't need us to validate its existence. It will continue long after our curiosity fades. That's what makes it timeless. It's easy to forget that the deep sea, for all its mystery, is part of the same planet we walk on. It's not somewhere else. It's here, directly beneath us, occupying most of the Earth's volume. And yet, it feels alien precisely because it doesn't revolve around human perception. The sunlight world we know, the forests, the cities, the clouds, is a thin film compared to what lies below. We live on the skin of a planet whose heart beats in darkness. The abyss doesn't belong to us. We belong to the small fraction of it that allows air and light. When people ask what drives deep-sea research if the environment is so resistant, the answer is often the same. Curiosity itself. The need to know what exists beyond reach is a defining part of who we are. But curiosity doesn't guarantee comprehension. Sometimes it's enough just to acknowledge that mystery exists. To let the unknown remain unknown is an act of respect, not ignorance. The abyss doesn't require us to solve it. It asks only that we remember it's there. There's a kind of peace in that realization. For all our ambition, maybe the deepest truth we can learn from the ocean is how to exist without demanding constant explanation. The creatures down there don't seek meaning. They are meaning, expressions of adaptation, of persistence, of quiet continuity. The vents don't question their purpose. The currents don't chase goals. Everything simply fulfills its role in the pattern of existence. That's not nihilism, that's equilibrium. It makes you wonder what exploration looks like in that context. Maybe it's not about pushing deeper, but about listening better. Maybe the next great discovery won't be something found miles below, but an understanding of how to live in alignment with systems that don't need us to define them. The dream of the deep might not be physical at all. It might be a philosophical one, an invitation to accept that we're temporary participants in a process that has no beginning or end. When you think about it that way, the abyss stops being distant. It becomes a metaphor for the kind of silence that underlies everything. The space between thoughts, the calm beneath noise, the quiet truth beneath language. It's not hostile or alien, it's just beyond articulation. Every time we stare into it, whether through a camera feed or a sonar map or just imagination, we're reminded of the limits of words. Some realities exist only in experience, not in expression. Perhaps it's not meant for us, not because we're unworthy, but because we're not required. The deep would exist perfectly well without our awareness of it. It doesn't need witnesses, measurements, or admiration. It doesn't even need to be seen to be complete. Maybe that's what draws us to it. We see in it a version of existence we can't emulate, pure, indifferent, self-contained. In a way, the abyss represents what we lost the moment we became self-aware, the ability to simply be without question. That's why, even as technology advances and exploration continues, there will always be parts of the ocean we'll never reach, not because we can't, but because we shouldn't. Those regions serve as a quiet counterpoint to our need for progress, a reminder that restraint is also a form of wisdom. The world doesn't need to be conquered to be beautiful. It only needs to be left intact enough to continue. And so, we keep sending our machines, not to possess the deep, but to listen to it, to witness its persistence, to understand our place in the vast structure of life. What we bring back are not trophies, but glimpses, moments of understanding that dissolve as quickly as they appear. That's enough. The abyss doesn't offer permanence, it offers perspective. It reminds us that we are temporary guests in a world that endures without us. Maybe that's what exploration was always supposed to mean. Not expansion, not domination, but the realization that existence itself is already an extraordinary mystery. The deep doesn't belong to us, but we belong to the same earth that made it. And in that connection, fragile and fleeting as it is, there's a kind of grace. The frontier remains unbroken, the silence remains vast, and the darkness continues to breathe. When we talk about the abyss, it's easy to think of it as something far away, a remote darkness that exists somewhere beneath us, detached and separate from the world we know. But the more we learn about it, the harder it becomes to keep that distance intact. The deep is not a place we travel to. It's a condition of the planet and, by extension, a reflection of ourselves. It's the physical counterpart of what we carry inside, the unseen, the unexplored, the quiet regions where thought slows and meaning deepens. The deeper we look outward, the more we begin to recognize that the abyss has always been within us too. There's something about the way we respond to the ocean that gives this away. When people stand at the shore, staring at the horizon, they often fall silent without meaning to. The sound of the waves, the pull of the tide, the rhythm of water against rock, it all seems to draw something still from within. That stillness isn't emptiness, it's recognition. We came from water. Every cell in our bodies carries its memory. The salts in our blood mirror the chemistry of ancient seas. The fluids that sustain us are direct descendants of the world's first oceans. We don't just live beside water, we're shaped by it. The abyss may feel distant, but it's written into our biology. That connection goes deeper than origin. It's also emotional. The human mind, like the ocean, holds layers, surface thoughts that shift quickly, and depths that move slowly beneath. At the top are the visible ripples of our daily awareness, reacting to every change in wind and light. Beneath that, in quieter regions, are the undercurrents, memories, instincts, fears, and desires that shape our lives without ever rising fully into view. And farther still, there are pressures we can't quite name, forces that shape our sense of identity the way gravity shapes the tides. The deeper we go inside ourselves, the less light there is, the slower everything becomes, the harder it is to measure. And just like the ocean, those depths are where the most ancient things live. It's no coincidence that we describe emotion in terms of depth. We say we're feeling shallow or deeply moved. We talk about drowning in thought or surfacing from grief. Our language mirrors the structure of the sea because the sea mirrors the structure of our consciousness. Both are shaped by gravity and motion. Both sustain life through hidden circulation, and both contain mysteries that resist simplification. The dark zones of the ocean are not empty, just as the dark zones of the mind are not void. They're dense with activity, teeming with processes we barely understand. If the ocean is the planet's subconscious, then we're the fleeting thoughts that pass across its surface. Every human story, every civilization, every invention, they all exist in the thinnest possible layer of the Earth's vast system. And yet, like foam above a wave, we reflect the movement of what lies beneath. Our culture, our art, our science, they're all shaped by unseen forces, patterns of survival and adaptation that trace back through millions of years of evolution. The ocean within us isn't metaphorical, it's genetic, it's chemical, it's historical. When we study the abyss, we're really studying continuity. The same processes that began life and sustain it still flowing through everything that breathes. The hydrothermal vents that feed entire ecosystems in darkness are not so different from the chemical reactions that spark the first living cells. The microbes that process minerals on the sea floor work in cycles that mirror the metabolism of our own cells. The deep is a reminder that life is not divided by environment, only by perspective. What seems alien down there is, in truth, the same story played out in another form. And yet, we treat that story as separate from ourselves. We talk about exploring the ocean as though we're entering foreign territory. But it's more like exploring memory. The pressure, the darkness, the cold, these are not obstacles to life, but conditions under which it once began. The earliest organisms evolved in environments we would now call extreme: high temperatures, toxic chemicals, no sunlight. Those conditions exist now almost unchanged in the abyss. When we send our machines into those depths, we're not venturing into the unknown, we're revisiting the origins of existence itself. The ocean remembers everything we've forgotten about survival without sunlight, without air, without comfort. That's why it feels familiar, even if frightening. Somewhere in our biology there's recognition. When we imagine the abyss, what unsettles us isn't its darkness, it's what it reminds us of. It mirrors the parts of ourselves we rarely face. The silence, the pressure, the endless motion without clear purpose. It's not evil or threatening, it's simply honest. The ocean doesn't pretend to be something it's not. It doesn't hide its cycles or disguise its decay. It transforms, recycles, and continues. It doesn't assign meaning to what it does, it just exists. And maybe that's what makes it feel so strange. It's a version of being we can't replicate. Modern life, in contrast, is built on noise and speed. We fill silence with constant distraction. We move from one surface to another, measuring value by visibility. The abyss stands as a contradiction to that. It's a reminder that existence can be rich even in stillness, that depth doesn't always seek attention. The creatures that thrive down there don't compete for recognition. They adapt quietly, efficiently, invisibly. The idea of thriving without being seen runs counter to almost everything in our culture. And yet, when you think about it, that's how most of the universe operates. Growth doesn't need witnesses. Continuity doesn't need applause. In this way, the ocean's depths hold a kind of wisdom. They show that balance doesn't depend on visibility or speed. It depends on endurance, on patience, on allowing change to happen at its own pace. Our obsession with control makes us forget that some systems function best without interference. The abyss doesn't need management, it needs respect. The same could be said for the deeper layers of our own lives. Not everything hidden needs to be exposed. Not every silence needs to be filled. The scientists who study the deep often describe moments of quiet revelation that have little to do with data. Watching the live feed from a submersible, seeing a fragile creature drift past the camera, realizing that it's existed in perfect balance for millions of years without ever being seen. Those moments change people. They shift the sense of importance. The human world, with all its urgency and noise, feels smaller for a while. The abyss doesn't shrink us in a cruel way. It puts us back into scale. It shows us how to exist as part of something larger, not above it. That shift in perspective has value beyond exploration. It's a lesson in coexistence, one that applies to everything from ecology to emotion. The ocean doesn't isolate its parts, it connects them through flow. Every movement, every change ripples through the whole. Our inner lives work the same way. What happens in the depths of emotion eventually rises to the surface, shaping behavior, creativity, compassion. Ignoring those depths doesn't make them disappear. It only disconnects us from their influence. The deep within us isn't a place to avoid. It's a place to understand. But understanding doesn't always mean solving. There's a danger in believing that everything hidden must be revealed, that every mystery must yield to analysis. The deep inside us, like the deep in the world, depends on darkness to function. The mind needs its unlit regions, the places where thoughts form slowly, where silence allows reflection, where not knowing keeps us open. We can't live entirely at the surface of awareness any more than the planet can survive without its oceans. Depth is not absence, it's foundation. In the same way that ocean currents regulate climate, the deeper emotional currents in human life regulate meaning. They shape culture, empathy and creativity. They drive art and philosophy, often without being seen. When artists and writers speak of inspiration, they're often describing something that rises unexpectedly from within, like a signal from below. It's not deliberate, it's emergent. It's the same principle the ocean follows. Patterns forming without direction, beauty emerging from balance. Perhaps that's why the abyss continues to fascinate us even when we know it's inhospitable. It represents something essential about being alive, the coexistence of fragility and endurance. We fear it for the same reason we're drawn to it. It embodies the scale of existence beyond our comprehension but within our connection. We recognize ourselves in its mystery, not because we understand it, but because we share its essence. Pressure, silence, persistence, transformation. In a way, we've never really left the ocean. We've only changed form. The water inside us still carries its rhythm. Our hearts beat in patterns that mirror the pulsing of tides. Our breath follows cycles of expansion and release that echo waves. When we're calm, we describe it as being at peace. When we're overwhelmed, we say we're drowning. Every metaphor we use pulls from the same origin. We are creatures of fluid and gravity, navigating between light and pressure. To deny that connection is to forget where understanding begins. If we look at the abyss not as distance but as depth, both planetary and personal, then it stops being a boundary and becomes a mirror. The darkness below and the darkness within aren't separate. They inform each other. The way we treat one often reflects the way we treat the other. When we exploit the deep, we reveal our impatience with mystery. When we ignore it, we echo our fear of introspection. But when we respect it, when we listen, study and protect, we acknowledge something fundamental about existence itself, that the unknown is not our enemy, it's our teacher. The more we align with that understanding, the more the boundaries between inner and outer dissolve. The ocean's circulation connects every molecule of water on Earth. Eventually, what evaporates becomes rain, what falls becomes river, what flows becomes sea. The same pattern moves through thought. What rises from the subconscious becomes idea. What's expressed becomes culture. What's shared returns to influence others. The cycle continues endlessly. The deep within us feeds the surface of our lives, just as the abyss feeds the world above. So perhaps the real exploration isn't downward, but inward. The machines can keep diving. The sensors can keep listening. But the most profound discoveries might not come from new data or deeper trenches. They might come from the realization that the same mystery we chase at the bottom of the ocean already lives in us. The same resilience. The same capacity for silence. The same patience. The same capacity to transform without needing recognition. We are, in the simplest sense, extensions of the same process that shaped the abyss. The difference is that we can reflect on it, put it into words, share it, and still not fully grasp it. But maybe grasping isn't the point. Maybe awareness is enough. The deep doesn't seek understanding, it embodies it. It exists as truth without narrative. To live with that in mind, to accept that not everything needs explanation, that some mysteries are meant to endure, is to live in alignment with the planet itself. And so, as the lights of another submersible fade into the black, as the instruments quiet and the pressure builds, the ocean returns to its slow breathing. Nothing changes down there, and yet everything continues. The world turns, the tides pull, the deep within and the deep without remain in conversation, speaking the same language of persistence and balance. And in the small space between those two immensities, the human and the planetary, there is understanding, not because we've solved the mystery, but because for once we've learned to listen,